So, hello everyone, and welcome to the afternoon of the Open Euler and Operating System track. So it's great to have you here, and we are starting right into it. I'm Mario Behlink from the FOSS Asia team, and I'm honored to welcome Dr. Xiong Wei, Executive Director of Open Euler, here on stage now. Xiong Wei is an accomplished figure in the tech industry, currently serving as the Executive Director for Open Euler, holding the position of Central Software Institute Server Operating System Chief Architect at Huawei's laboratory. Since joining Huawei in 2014, he has played a pivotal role in the development of the Open Euler project. He initially established the Kunpeng basic software stack server OS, container engine, and other infrastructure of the Open Euler project. His expertise extends across a broad technical spectrum, including processor architecture, operating systems, and containers, backed by years of experience and technological innovations at other companies like Turbo Linux and Wind River. Also a distinguished background in educational area from Nankai University. Xiong's academy background laid the foundation for his extensive career in operating systems underlying software. His tenure includes significant roles as the Euler OS Chief Architect at Huawei's Technologies Senior Manager at Wind River and R&D Director at Turbo Linux China. Thank you very much for joining us here today, and I hand over you to the welcome of the Open Euler track.
It's very happy we have so big a hall to hold Open Euler's track. And yesterday in the keynote, I do a brief introduction of Open Euler, what it is, and what's the label, the technical label of Open Euler, and what's going on, what will happen in the next stage of Open Euler's development. But nowadays, I think I want to emphasize that Open Euler is an innovation community. So in Open Euler, we have developed a lot of totally new projects which cover DevOps, cloud native, security, and AI, and also embedded, a lot of this kind of area. There are over 400 projects which is totally new, and welcome any developer, the worldwide developer, to getting those kind of projects, to get involved in new innovation ideas. So for this afternoon, I think we can bring some of the projects which are very interesting, and they are very important, and also it's some kind of material which can bring those new technology to our audience, to our developer, or even our partners. So I believe those kind of projects can bring a lot of new ideas, or bring a lot of opportunities for the young developers. So I think that is the track's value. So next time, I think we can let's to start this afternoon's track. Hope everyone here will enjoy the technology details and the high-tech values.
Okay, thank you very much, and big round of welcome applause to Open Euler. Yeah, and the next first speaker here, I would like to welcome now on stage is Yanjun Wu, Institute of Software and Chinese Academy of Science, and standing committee member of Open Atom, Open Euler community. Open Atom is a foundation in China, and I'm very glad to welcome you here on stage. So we've set up your stage here. There's the system and this, or you can choose the microphone. Whatever you like. So thank you very much for joining us here on stage. Thank
you. Good afternoon, everyone. Glad to be here to give a brief introduction about Open Euler's future. So I'm Yanjun from Institute of Software, Chinese Academy of Sciences, and also standing committee member of Open Atom, Open EULA community. So the topic today is Future Unfolded, exploring the vision of Open EULA. First, I would like to give some latest data about Open EULA. This data is just updated this morning. And we can see we have already have 11,000 repositories, 162,000 pull requests, and 1.3 million global downloads. And most important, we have more than 1,500 enterprise members, and we have 18,000 contributors. So Open EULA is actually a very large community. And go back to 4 years ago, Open EULA is just about 1% market share in China server operating system. But at the end of last year, we reached more than 36%. So it's a really fast-growing OS distribution. So, but however, that is not my topic today. My topic today is where shall we go? Where we are going to do in the next step. So as we all know, that intelligent computing era has arrived. We can see a lot of new hardware technologies like no voluntary memory, domain-specific architecture, high-speed communications, and as well as energy constraint. On the other hand, we have diverse new application demands. So here we take operating system as innovation engine to meet versatile scenarios. How we achieve this? From two aspects. One aspect is operating system for AI, and another is AI for operating system. So here's the details. On one hand, we offered end-to-end AI DevOps, like programming assistance. We have EULA Copilot, which has been mentioned this morning, and we have AI shell command for auto-completion and recommendation. We also have we are also working on coding compilant like Copilot X from GitHub. So we also did a lot of things to improve the performance of Open EULA, from the AI configuration, AI tuning. On the other hand, we have AI assistant operation and management. We offer a lot of AI frameworks, libraries, drivers, operators. We also encapsulate AI apps in containers like Docker and like Isola. Also, we support heterogeneous hardware with unified scheduling, and we also improve the inference by concurrent inference more than 50%. So as Dr. Xun has mentioned yesterday, we have a lot of developers, like 18,000 developers. So we have a collaborative development for full stack innovation. And now we have more than 400 code repositories for innovation projects, with an average of 10 new innovation projects each month. So Open EULA is not just for server operating system, but also for many other scenarios, like cloud and embedded computing. We have already employed Open EULA to some typical scenarios, like multimedia conference, smart factories. We now build Open EULA as a contribution platform for global developers with other open source foundations. For example, Open EULA has already had native support for OpenStack. This has done with Open Infra Foundation. The members from Open EULA has already been the leading kernel contributors. And we also have many native support for major projects in Linux Foundation. We also give full stack native support for big data, like Spark, Flink, under Apache Foundation. And Beijing GDK, which is compatible with OpenGDK, also had the compatibility certification from Eclipse. So we also have many communication platforms for global developers like LinkedIn, YouTube, Twitter, Reddit. We have, in order to, for the convenience of global developers, we not only hosted our projects in Git, but also in GitHub and GitLab. So if you wanted to experience OpenEULA today, you can download from the website with different images, like ISO images, cloud images, container images. We also have a Windows subsystem for Linux WSL version of OpenEULA. You can also use virtual machine to install OpenEULA, and you can also play with Raspberry Pi. So last, but I think the most important part, I want to give a brief introduction about Open Source Promotion Plan, OSPP. I think this is very important for students here today. This OSPP is initiated by ISCAST and OpenEULA from 2020. It's an alternative to Google Summer of Code. I think many students may heard of Google Summer Code, GSOC. GSOC started from 2005. Actually, I was a student at that time, and I was one of the first participators of GSOC. So from 2020, we started an alternative to GSOC called OSPP. We want to bring mentors from communities and students from universities to make contributions to open source. So this year is summer 2024. It's the first year. We have more projects, more mentors, and more fellow students. And specifically, we have many students from different countries, like Europe, like British, France. We also have students from Canada, American, and also have students like from India, Pakistan. But it's a pity that till now we don't have students from Vietnam. So we strongly welcome mentors and students from Vietnam to join in OSPP. And then together we build a shared future. This is my talk today. Thank you very much.
Thank you very much. Yeah. So I just wanted to ask you about the last slide. That is a student program. When will be the next season, and when can people apply for it? One second. Yeah.
Yeah, there's an official website. Maybe you can take pictures from that slide. And there's a guide menu for students from different countries, to 4 countries. There's an English version of the website. You can visit.
Yeah. So please take out your phone and take a picture of this so you have it as a memory. Hồng Phúc, can you please say this in Vietnamese?
Yeah. Mấy bạn có biết tới cái chương trình này chưa vậy? Chưa, thì nên chụp hình tại cái chương trình này, giống như là chương trình mà nếu mấy bạn có tham gia với Google Summer of Code đó, còn cái này là của OpenEULA thì có giải thưởng rất là cao, là cái này là lớn nhất mà bên Huawei tổ chức cho toàn cầu, những trên thế giới rất là nhiều người tham gia. Thì cái này là mở cho sinh viên vừa học được rồi người ta lại có mentor lại hướng dẫn nữa. Đây là một cái chương trình Global Coding Program rất là lớn. Thì chị muốn nhắc lại là khi các anh này nói chuyện, cái nào mà các bạn không rõ đó thì trên cái tường có cái scan để mà translation, các bạn có thể scan cái đó để mà đọc theo cái translation. Có câu hỏi gì không? Bạn này có câu hỏi gì không? Thì khi mà mình đi học đúng không? Thì chị mình ở trường học thôi. Còn mấy anh này là làm trực tiếp tại những công ty luôn, là làm trực tiếp những công ty lớn. Chẳng hạn như là muốn ra trường, muốn có việc làm thì muốn biết được có là technology nào mà sử dụng ở những công ty á. Có câu hỏi gì có thể đặt ra câu hỏi. Thì chỉ có cái bạn translation ở đây á, em có thể nói bằng tiếng Việt thì các bạn sẽ dịch lại. Cái bài này nghe có gì khó hiểu không?
Okay, I know nothing about what Hong said, but it's very, I think it's a very successful project in China. There are a lot of Chinese college university which they can apply the case or project, and the money is not so much, but it's very interesting that if you take some project and finish it, and the project will funding some money. So for student, maybe Dr. Wu, you can explain the money about the project.
So the standard of accomplishment is not only to submit pull requests, but also has been merged into the project's mainline. So money, you can see it 8,000 and 12,000. This is two different levels. The 8,000 for the simple, the basic levels, and the 12,000 for hard, advanced levels. So this is two levels. So I think it's not easy. Maybe it is not easy, but I think through this process, just like Hong said, I can guess that you get a lot of technology open source experience.
So not only about the price, but also about the experience and the knowledge they will gain, so that they can prepare themselves for the industry later on after the universities. So this is what you want to say, right?
Yes.
Hồi nãy anh này nói là cái số tiền thì không bao nhiêu, nhưng mà các em thấy đó, bao nhiêu đổi ra 3 tháng là 27 triệu thì cũng được đúng không? Nếu mà viết code vừa đi học mà vừa viết code 3 tháng 27 triệu thì cũng đâu có ít lắm đâu. Rồi sau là cái giá rồi là cái 8.000, còn cái 12.000 là 47 triệu thì cũng đâu có ít lắm đúng không? Hồi xưa chị đi học đi làm cũng đâu kiếm được cái số tiền này. Thì vừa có thể học được, vừa có thể là có kiến thức, mà vừa có thể đảm bảo cuộc sống, hỗ trợ cho mình luôn. Thì các em có thể xem thì yêu cầu á, tại vì á, ở bên đây người ta có một số cái phần mềm open source. Thế cái chuyện mà các em phải làm đó là tìm hiểu về cái phần mềm này và viết code. Thì mỗi lần các em viết code đó, thì nếu mà cái code của em á, được merge vô cái phần mềm này á, thì coi như là thành công, đúng không? Thì họ đang, lý do mà cái đội này họ ở đây là tại vì họ muốn tìm những cái bạn mà talent ở Việt Nam để contribute vô những cái open source project. Thì open source project đó là contribute for good cause, đúng không? Tại vì nhiều người cùng có thể sử dụng, vừa có ích cho sinh viên luôn, mà vừa có ích cho cộng đồng. I'm sorry.
So who would be interested generally to become a summer intern for OpenEuler and Huawei and these kind of projects here? Who would be interested? Show me your hands.
Có ai quan tâm tới cái chuyện này không thì giơ tay. Có ai quan tâm giơ tay lên các bạn. Giơ tay lên, có gì đâu mắc cỡ.
Yes. Okay, so quite a few people, yeah? Okay, cool. So yeah, some insights here. So it's up to 42 million Vietnam dong. Yeah, up to 42 million Vietnam dong. I think it's quite nice for a summer internship. So I don't think it's low. So it's really good. And so we've talked about this. We've talked about the opportunity for you guys here in the room, and of course for everyone in Vietnam, but around the world. And the question now is, how can you start? How can you start your career in this sector, in Linux, in OpenEuler, and in the technology scene? And this is about the next presentations that we have now to learn more about the technology. And we have the next speaker coming up. It is George Kao. So George, please come on stage. And yeah, I would like to share quickly few facts about George. So George is a senior software engineer of Open Euler. He serves as a software engineer in the community, where he plays a pivotal role in shaping the community's infrastructure. As a maintainer of the infrastructure SIG group and a member of the technical committee, George's responsibilities span across crucial areas, including community CI/CD, service pipeline construction, and comprehensive community membership and a repository management. So quite a lot of responsibilities here, and yeah, we are eager to learn more from you about this. Here, the control, the microphone online, or just take this one.
Okay. Okay. Good afternoon, everyone. I'm George from infrastructure team of Open Euler community. Yeah. Glad to be here to share with you the development of Open Euler and how Open Euler struck to be a developer-friendly community, the topic of my speech today. Yeah. Okay, I will introduce you from the following four aspects. Our team overview, cloud native DevOps, cloud native application design, and the future plans. First of all, the infrastructure team overview. The infrastructure team is one of the earliest teams built in the community. After 4 years of the development, we have established 5 special interesting groups. They are Infrastructure SIG, Gatekeeper SIG, CI/CD SIG, Open Design SIG, and the Reproducible Build SIG. Yeah, our team members has grown from 5 to nearly 20. The scope of our work is also expanding. We are mainly responsible for the community development process, such as code hosting, the pull request check, package building, and software signature. We also support the community operations, such as community website, member management, meeting management, and email service, and the data dashboard. Yeah. So we are going to talk about the infrastructure landscape, and you can look at this picture. Yeah. As you know, Open Euler is a completely open source community. So when we build our own infrastructure, most of the services are developed from open source projects of the well-known community. Take a look at this one. Take a look at this one, GNU Mailman. Maybe you have used it before, which we use it as our mail list service. We also use Jenkins to build CI pipeline and OBS from OpenSUSE to build and distribute our packages. You may also find a bunch of projects from the CNCF. Yes, we have the Nginx Ingress, which is used as our reverse proxy server and as a simple API gateway. Argo CD is also used to centralize our applications, changes, and code into our production environment. We also use a Vault, Vault from HashiCorp as our sensitive data background, as well as Corpora. Corpora is from Fedora, and we have enhanced the Corpora in several ways to make it running better in a corporate cluster. Yeah, lots of projects. This part, I will give you the overview of infrastructure architecture. Actually, there are 2 tiers in our infrastructure. For the first tier, we use Terraform files to centralize and to create all the basic IaaS resources, includes the VPC, database, storage device, the virtual machine, and the physical machines. For the second tier, here is all about the Kubernetes clusters. We have master cluster to run key components, and the worker cluster to run different applications in different regions and different clouds. Now, we have 160 servers, 6 Kubernetes clusters, and more than 300 virtual machines to support nearly 20,000 developers in Open EULA community. Yeah, it's a huge infrastructure. Okay, we are going to the next part. It's about cloud native DevOps. I will share some experiments and some best practice with you on how we deploy application in the cloud native way. There are 4 parts. Yeah, the first part is about deployment standardization. Most infrastructure services of the Open EULA community are deployed on the Kubernetes cluster. So services need to be containerized. Containerization brings us many benefits, such as easy migration between different clouds, easy tracking of every deployment change, and reduced deployment time and application recovery time. So we have made some efforts in standardization. Containerize application, change log outputs, manage image repository, and health check. The second part is about configuration separation. Yes, in the whole service deployment process, we divided different responsibilities by application developer, DevOps engineer, and infrastructure maintainer. Yeah, application developer are only responsible for service deployment and container constructions. DevOps engineer are responsible for service resource interconnection, such as ingress and database configuration. Infrastructure maintainers are responsible for service release and use Argo CD to centralize services on IaaS resources. Okay, the part 3 and part 4 is about GitOps and automation. Part 3, we use Git repositories to store configuration files and to centralize with Argo CD while deploying infrastructure services. In this way, services can be quickly brought online, historic versions can be managed, and service reliability and security can be further improved. The last part is about automation. Actually, there are 3 different cases. Take a look at this one. This picture shows from pull request submission to website preview, from code merges to Jenkins build and publish, from new configuration files to service cache clearing, and to notification. All steps are automated. Okay, we are going to the next part. During this part, I will share some useful applications that we have been working on to make them better running in the Kubernetes cluster. The first one is about bots. So if you guys have ever been in the open source communities, you must have learned that there is a bot application used to collect all the different applications into the pull request. For example, if the developer submits a new PR, the maintainers will use the bot application to check the commit to perform the CLA check, as well as sign or unsign a PR for someone and post comments on the pull request. Our bot application is named Yabert, which is based on the idea of Pro project from CNCF, and we proved it through several aspects. The first is robust. It means each single plugins will be separated in the container, and it's easy to replicate it. If one of the plugins crashes, it does not affect the whole application. Yeah. The second improvement is about the highest throughput. Yes, we use Kafka to receive the message from the code platform as well as the delivers. And other improvements focus on multiple platform support and multiple developing language support. The second application is the meeting bot. Yes, have meeting is an essential requirement in the community. As we have about 10 meetings per week, so we have created our own version of meeting bot. Our meeting bot supports multiple meeting platforms such as Room, WeLink, and Tencent. And you can book meeting via website or WeChat app. Rewatch the meeting video via YouTube or Bilibili. Actually, the architecture of the meeting bot is quite simple, and most of the job is done by Kubernetes. Once the meeting event comes, we will use Kubernetes to create a meeting, to send the email to our maintainer, to down our meeting videos, as well as publish it to social platform. Okay, we are going to talk about the Signal Trust. Signal Trust is a project based on the idea of OBS sign from OpenSUSE while provide a more comprehensive and efficient and cloud-native solution for package sign. It's end-to-end security design with high throughput. It can support almost all binary files. Yeah, and has a user-friendly key management. Yeah, sorry. Yeah, sorry. The next one is MOOC Studio. MOOC Studio is based. Oh, sorry. Yeah. Why this? Why this one? Okay. Yeah. Why?喂，这个是怎么回事？它一直在要放呢，我把它弄到上页，还是直接就过去？自动这儿取什么？自动也是吗？我直接。Okay, sorry. The next app is MOOC Studio. MOOC Studio is based on Kubernetes operator and provides an open URL terminal environment for community developers, especially for developers comes from university or high school. Yeah, it's a common case that there are some troubles to get a real environment. So especially for the Arc environment to run the operation system. In order to solve this problem, we have developed our MOOC Studio. MOOC Studio is a kind of native terminal playground in a browser. It has some good points. Yeah, first we can establish collection to brand new environment in only 20 seconds. Second, it supports multiple environments such as application container, system container, or virtual machine. Third, the environments can be quite highly customized, include base OS, architecture, or additional files. Yeah, the last one is the environment will be released when disconnected. This part is about EUR. EUR is short for Open URL User Repository. Actually, it's based on Corpora project from Fedora, but the components has been customized for Open URL. First of all the components has been upgraded for Kubernetes environment. Yeah, and we use serverless Kubernetes port as a backend package builder. Second, it can reserve package dependency and auto import. And EUR is highly integrated into our package development process. Okay, this part we're going to talk about our future plans. The first one is software marketing. We will do our efforts to provide a convenient platform for community developers to query and to obtain software. Second one is the Cloud IDE. We will support developer and test the process with Cloud IDE. Third one is Message Center. We will integrate all application with Message Center by Cloud Event. Okay, you can scan the QR codes and visit the website here to join us. Okay, thank you everyone. Yeah.
Thank you very much. Thank you. And yeah, so, before we check if we have a question, we would like to have a short wrap-up in Vietnamese. Excuse me? Yes, we have a short wrap-up in Vietnamese. We just need the microphone here, and so we can have be sure that everyone understands about this session. Yeah, please go ahead. Your wrap-up. George. Yes.
Vâng, xin chào tất cả mọi người ạ. Vậy thì là mọi người đã vừa được nghe về chia sẻ của anh George Cao về gọi là những cái giới thiệu về Open Euler, đúng không ạ? Vậy thì là trong những năm qua thì là cái nhóm cơ sở hạ tầng của Open Euler thì đã cố gắng đưa cái doanh nghiệp của họ đến gần hơn với các nhà phát triển. Và trong buổi nói chuyện này thì là kiểu như là họ đã muốn là chia sẻ những cái dự án mà họ đang thực hiện ở hiện tại. Ví dụ như là ứng dụng về Open Euler, WSL, Euler Launchers, LXC, Offstack hỗ trợ, thì đấy là những cái thứ mà những cái dự án mà họ đã được làm trong những năm vừa qua. Thì là sau đó thì là họ đã sẽ cố gắng giới thiệu những cái nền tảng ký kết để hoàn thiện nhanh chóng những cái dự án của họ. Thì ngoài ra thì là cái việc ký kết nhị phân này nhanh hơn và an toàn hơn, thì cuối cùng là họ sẽ nói về những cái kế hoạch tương lai của họ về trong việc xây dựng cái cơ sở hạ tầng của họ như thế nào. Thì đó là những chia sẻ mà anh George Cao đã muốn chia sẻ đến tất cả mọi người trong bài phát biểu vừa rồi ạ.
Good.
Okay, we're finished.
Thank you very much. So yeah, are there any questions in the audience? Any questions? At the moment, no questions, but I think there will be more questions probably later. So, George, you will be at the booth, at the Open Euler booth, so people can come directly to you with their questions.
Can correct us from the...
Yes.
Yeah. You can correct us, scan the QR codes or visit the website to correct us. Yeah.
Okay, cool. Thank you very much. Thank you very much. Big round of applause for George. And we're coming to the next session here in the Open Euler track, which is, 1 second, have it in a moment. So we are here with the introduction to AOPS, an intelligent operation and maintenance platform of Open Euler. I'd like to ask Yunqing Zhu, yeah? Here comes already on stage to set up. So let me share a few key facts about Yunqing. He's a software engineer at Open Euler and yeah, very dedicated engineer, working directly at Huawei, contributing significantly to the open source community, particularly within the Open Euler project. As a major force behind AOPS and intelligent operation and maintenance software tailored for operating systems, Yunqing brings innovative solutions to enhance system reliability and efficiency. He holds the role of a committer in the Open Euler Ops SIG, where he is responsible for maintaining multiple AOPS repositories. Yunqing's expertise and commitment to advancing open source software development underscore his valuable contributions to the Open Euler community and the broader field of software engineering. So, thank you very much for being on stage. We're still setting up for in a moment and then get started. So in the meantime, so we're also of course interested how many people already use, for example, Linux, how many people use different operating systems. So just a quick check in the room, so we have an idea where we are. How many people in the room have a desktop and already use, or the microphone dropped out sometimes. how many people already use Linux? How many people already use Linux on their desktop? Okay, yeah, okay, quite a few. Okay, how many people use Mac OS, for example? So just so we have an idea. Ah, okay, yes. Okay, some people both. Yes. Ah, okay, I understand. So, and other people like maybe Windows operating system, yeah? How many people? Yeah? Okay, so, and the others probably mainly on the mobile phone using Android. And yeah, so we have an idea and getting started now. So thank you, you let's say it correctly, Zhu Yun Cheng. Yes?
Exactly,
Okay, excellent. Thank you very much for teaching me that. Thank you. Big round of applause. Welcome.
Welcome everyone. I'm Zhu Yun Cheng. I'm a software engineer in Huawei, and I have been working in the operation and maintenance area for about 3 years. And I also actively involved in the OpenLab community as a commuter in ServerSig. And I'm glad to be here and share with you all our latest progress about the project called AOPS. Yeah, here I'm gonna introduce it from the 4 aspects. So firstly, what is AOPS? So broadly speaking, AOPS is an end-to-end solution for user to for detection and diagnosis and repair. So here we divide the whole process of the maintenance work to 3 layers. The bottom layer, we call it data collection layer. Here we have an agent to collect the data from user's host. We have an agent to control many different collection tools to collect. And the data includes the metric data as well as the log data. And one of the most important tool is called GuardGopher. So it uses eBPF to collect very deep level data from both and user mode. And the middle layer, we call it initial diagnosis layer. So in this layer, we can still use some tools to conduct some initial diagnosis so that we don't have to push the heavy data to the outside. For instance, if you want to try to diagnose the OOM right out of memory, you don't have to transform the VM core to outside, which is very heavy. And the top layer, we build a set of microservices and support many features, so user can, for instance, do the routine inspections and AI diagnose and CV hotfix and other many interesting features. And for user to scan and repair the entire cluster, not only one. So here I'm gonna introduce the AOPS 3 main features. Firstly, is the full stack observability. It is provided by GuardGopher, which is a daemon that provides a lot of eBPF-based probes combined with the uprobe and tracepoint and kprobe to collect the data from the kernel and driver and syscall. So it's very convenient for user to develop their own plugin. Yeah. So right now we have covered the kernel runtime and some other user mode software like Redis and Nginx. So as you can see, when we got the data from the probes, it can be stored as a matrix in the database, for instance, Prometheus, right? Or it can be transferred via Kafka to for other use. And with the data we have, we can do many interesting things, like we can draw a real-time topology based on the TCP or IP communication data. And with the topology, we can do the cluster fault localizations with data like the response time or latency of the request. You can easily localize the fault, and you can see which part of the cluster is wrong. And finally, you can also do the fault diagnosis. We have covered like I/O and memory and even performance. You can do the online performance profiling, yeah, which is pretty cool. Here is some charts made by the GuardGopher. You can see it covers most of the useful data we can use in daily maintenance work. like the applications API performance and the TCP IP data, and also they can draw the flame graph of the CPU or memory. And they can also do the online profiling based on the on-CPU or off-CPU analysis. And another function of AOPS is vulnerability management. As we all know, the security of OS is very important, right? And OpenOla publishes the update version every week. So, for instance, if you have a CVE in your kernel, you can just download the upgraded one to upgrade the kernel and then reboot the system, and the CVE will be fixed. But in most cases, this will be work. But in some emergency cases, so user cannot just reboot the system and activate the new kernel, right? So we can use the hot patches. And here we build a brand new hot patch production pipeline, and to produce the pipeline with the code patch PR, which I will describe later in the demo. And with the published hot patch, we can scan the host in the AOPS website, and we can also generate a fixed task to define the host you want to fix and the CV you want to fix, and even the fixed way, like you want to use code patch or hot patch to fix the CVE. Then after the the CVE is fixed by code patch or hot patch, we will scan it again, and we will update the state in our database. So since we can scan and repair it in batches, the efficiency is very increased significantly. And how do we manage the hot patch in the system? So we try to be consistent to users' habits. In OpenOla, we use DNF to manage the packages. So here we just develop another DNF plugin to manage the hot patch life cycles. And you can see here we support different commands of the DNF to scan the CVE and also install and upgrade the hot patches. And in the lower level, we actually call the Syscare using the command line. And Syscare is another open source project in OpenOla. It unifies the Kpatch and UPatch external interfaces, so it is easy to manage both of them at the same time. And it also provides a complete lifecycle management from the not applied to deactivated, then active. And the traditional hot patch will be deactivated after you reboot the system. So the CV will be exposed again, which is not what we want. So here we add a new state called accepted. So if you accept the hot patch, means after you reboot, the hot patch will be active again automatically, which is pretty cool. And so the final feature I want to introduce is the configuration tracking. According to the statistics of our maintenance and SRE team, we found that over 80% of OS failure caused by the changement of configurations. Like if you change the /tab, it easily can cause the boot failure, right? And here we set the baseline of the host, and we will regularly scan all the hosts and report the detected modifications. And we will also do the version control of the configurations. Yeah. And so finally, we have a future plan of combining the GPT with our AOPS. So we try to, we have chosen the GPT called LogGPT to help us to predict the next line of the log, so that we can compare the prediction log with the actual log to see if there is anything goes wrong. So we can just give the model the log file, like the messages file, and the code file and the case file of the maintenance work. It will do a great job and help us to tell the log if have anything wrong, not just give them a specific rule, right? Okay. So here I prepared 2 demos for hotfix. The first one is how we made a hot patch in the community. So firstly, we just find the PR in the kernel repository. And here, I just randomly pick one. And here we just need to comment here, make a comment here. Here I omit some parameters. And it will automatically trigger a new PR in the hot patch meta repository. And in this PR, it will record some basic info about the hot patches, like which source RPM I'm going to use, and which debug info RPM, and the specific content of the patch. So the PR will start running with the CI system. And after the build is done, we will test it in community. And you can also see the anniversary we have published here. So here are the anniversaries we have published, and you can see the detail of about the CVE, and also you can download the hot patch online. Yeah. So with the metadata on the PR, you can actually rebuild the hot patch by yourself. Okay, the next PR, the next demo is a demo show how we fix it by AOPS. So firstly, we log in and we have a dashboard here to show some basic info about the cluster. And here we can see all the hosts we have in the cluster and their like online status. And we can also add the host in batches with Excel. Here we can also separate them in groups. And in the CVE page, we can see all the hosts we have, all the CVEs we have in the cluster, and how to fix them, the specific RPM and their version. Then we can, we can also see how many CVE we have fixed. And we can also see the CVE from the host perspective. So here we just enter one host and we can scan it. And we can also export the CVE information about the host. It will generate Excel, which shows the detail about the host CVE info. Yeah, so here I just choose the CVE which can be fixed by hot patch. And here we choose hot patch to fix the CVE and generate a task. So here I accept the hot patch to activate even after reboot. So then the task start running, and we can see some detail in the task. So after the task is done, you can see the log of the task. Basically, it's a DNF log. And if you regret to, here I just show the CVE has been fixed, right? And we can also see the hot patch status by our hot patch plugin. And if you feel regret to fix this CVE, you can also generate a rollback task. And after rollback, it will change to the previous state. So here, when we list the CVE, list the hot patch again, it is gone. Yeah. That's it, and feel free to scan the QR code. Thank you, guys.
Okay, thank you very much. I'm sorry about that, but yeah. So yeah, please stay here a moment so while we have a wrap up in Vietnamese about this session.
Xin chào tất cả mọi người cũng đã được nghe buổi giới thiệu về AOPS, nền tảng vận hành và bảo trì thông minh của OpenOiler. AOPS là một nền tảng vận hành và bảo trì thông minh dành cho các hệ điều hành, được phát triển trong OpenOiler trong 3 năm. Trong bài phát biểu thì họ đã nói chúng tôi đã giới thiệu về những kiến trúc cơ bản và các tính năng và các cải tiến chính của AOPS, chẳng hạn như quản lý lỗ hổng và truy xuất nguồn gốc cấu hình. Sau đó chia sẻ các kế hoạch trong tương lai và chuẩn đoán thông minh của các khía cạnh khác.
Thank you very much. And any questions here? Actually, this is AI related. You could have also bring this talk to the AI track, but we had another AI talk from OpenOiler. So AI is a big topic nowadays.
Yeah, exactly.
So you have big plans with your own GPT. Any specifics, any algorithms you're planning to use? Can you tell us already a little bit about that?
Actually, we are, we are working with Ola Copilot team to try to combine them together so that you can use the Ola Copilot to call our AOPS.
Yeah. And what about support for Vietnamese languages?
Support languages?
For Vietnamese?
Right now we have support English actually. We will try to support Vietnam. Yeah.
So anyone interested who like in supporting Vietnamese in this project, so could for example work with you, or for example become an intern over the summer with a coding program, correct?
Yeah. Exactly.
Okay. Cool. Then thank you very much for this interesting session, and we're looking forward to hear more from you in the future. Thank you very much.
Thank you.
Good. So we're coming to the next talk. The next talk is Introduction to Open Euler Community Unified Construction Platform, Euler Maker. And while we set up, I'm already sharing a bit about the speaker. It's Xia Senlin. Xia is the family, and Senlin is the given name. That's correct, right? Yes. And let's hear a bit about Xia Senlin. So he's a software engineer from OpenOiler, proficient software engineer, deeply involved in the community, particularly within the CI/CD SIG, tasked with the roles of overseeing the daily community version building and release processes. Xia's contributions are fundamental to the community operational excellence. He spearheads the development, launch and promotion of the Euler Maker system, an innovative platform that streamlines RPM production, software layer customization and image customization. Through Xia's efforts, the Open Euler community benefits from enhanced efficiency and customization capabilities, solidifying the foundation for continuous development and deployment of open source solutions. Yeah, this is really great. So open source, of course, like it's a big topic, and we want to hear all about it. So we're gonna change the laptop though. Okay, make that happen. I have a question. So RPM, that's kind of widely used package management foundation for package management, and there are different platforms using it. So if you've ever worked on one of these areas, then you can also use it here in the platform. And setting it up, having the
大家下午好。我的英文不太好，所以今天我的演讲用中文进行啊，抱歉。
Anh ấy đang giới thiệu bởi vì anh ấy bảo là tiếng Anh của anh ấy không tốt, cho nên là anh ấy xin được dùng tiếng Trung để giới thiệu ạ. Và bài diễn và anh ấy sẽ bắt đầu ạ.
我叫夏森林，是来自华为的软件工程师。我在 OpenOla 社区担任 Application Desktop、Ruby、Runtime 以及 EPOL-SIG 的 Maintainer。今天我来为大家介绍 OpenOla 社区统一构建平台 Ola Maker。我是 Ola Maker 的设计者和开发者之一。这是我今天介绍内容的章节。首先，我为大家介绍我们为什么要做 Ola Maker。首先，我们对社区的 OpenOla 社区的用户做了用户分析，大概分为这3类用户。第一类用户是社区的开发者，他们一般是个人开发者，遍布全世界。他 他们关注的是自己的软件如何设计和实现，并且希望自己的软件在 OpenOla 社区能够尽快的引入、发布和更新版本，以此来提升自己在社区的影响力。他们的开发环境一般是个人电脑，对于他们来说，构建的痛点。对于他们来说，他们的构建痛点有4个。首先是构建环境受限，第二个是软件包构建时间比较长，第三个是很难去分析自己提交的 PR 对其他人的影响，最后是在现有的构建环境上很难去调试问题。第二类用户是 OSV 和嵌入式的厂商，他们的团队规模在几十到100人之间。他们期望自己参与贡献或者主导的软件包或者镜像能够按时和高质量的发布。他们关注的是收入回报和个人的成长。然后他们本地的构建环境是自有的服务器，然后部署在第三方构建平台。对于他们来说，他们的构建特点也有4个。首先是同样不能够去分析自己提交的 PR 对于反向依赖包的影响。第二个是很难够因为构建结果丢失很难够去复现。第三，定制的软件包没有办法支持分布式构建。第四是没有办法进行镜像定制。最后一类用户是 OpenOla 社区 OS 的 maintainer， 团队规模在几百人左右。他们关注的是社区的繁荣发展，然后构建一个基础的数字化平台。他们关注的是社区的影响力和 OS 的基础能力。构建环境一般是自有服务器、云环境，同样也是部署在第三方的构建平台上。对于他们来说，构建痛点有3个。第一个是因为基于第三方构建平台部署的构建环境没有办法进行有针对性的构建效率提升。第二个是构建服务器的镜像和嵌入式的镜像是2套割裂的系统，没有办法统一管理。第三个是 OSV 厂商本地的构建环境多种多样，没有办法接入到社区来复用社区的已有的构建能力。那么基于上面的用户分析，我们梳理出了不同的构建场景，包括单包构建、PR 门禁构建、全量或者增量构建、分层定制、镜像定制，还有镜像构建和镜像定制。接下来我来详细介绍一下 Ola Maker。Ola Maker 它首先是一个软件包构建系统，完成从源码到2进制软件包的构建。其次，它允许用户通过搭积木的方式组装和定制出适合自己需求的一个场景化的 OS。那么 Ola Maker 的功能板块就可以分为3个，即软件包构建系统、分层定制还有镜像定制。Ola Maker 针对软件包构建系统，提供了一个分布式的构建能力，包括单包构建、全量构建、增量构建这些场景，然后通过按需构建和资源的动态扩展，来加速这个构建效率。针对分层定制，Ola Maker 提供在一个公共的 Base OS 基础上，然后提供软件包的定制能力，也可以提供芯片层和面向服务器、边缘云、云计算、嵌入式这些全场景的 OS 定制。最后 ，Ola Maker 针对镜像定制，它允许用户可以自定义一个软件包范围和配置项，来输出包括服务器、容器、嵌入式虚拟机这些各类镜像，来实现用户的按需裁剪和极致裁剪的诉求。然后我来详细介绍一下 Ola Maker 软件包构建系统的主要能力。首先是 DAG 调度。DAG 调度它一般有这4个主要的功能。首先是预测构建任务的总时长。当用户在工程上触发一个新的构建任务之后 ，DAG 模块它会基于这一次任务的软件包范围，解析它们的依赖，生成一个 DAG 图。然后图里的每一个节点是软件包。它的边长就是这个软件包历史的构建时长，这样的话来分析它的一个最长路径，得到本次构建任务最长的构建时长。第二个能力是基于退出条件判断，来保障构建依赖是最新的条件下，再对当前软包进行再构建。 第三个能力是实时找环、实时破环，将串行构件转变为并行构件，用算力换时间。第四个是基于软件包 ABI 的变化进行减支，来减少不必要的软件包的构建子任务。那么 DAG 在确保构建依赖最新、构建结果一致的前提下，也在一定程度上完成了这个构建加速。软件包构建系统的第二个能力是弹性调度和任务优先级。我们观察了包含大规模任务的构建场景，常常发现在整个构建机集群资源占用率较低的情况下，还有个别的机器任务跑满。我们分析了，发现有这3个问题：第一个是软件包构建子任务的大小不一；第二个是软件包构建子任务的数量骤增骤减；最后一个是部分软件包的构建任务是需要优先处理，但是它还在排队。那 OlaMake 为这3个问题也提出了解决方案。一方面是 OlaMake 使能构建机自动计算软件包构建任务占用的资源，通过自动学习历史构建任务的占用资源，来为新的任务合理的分配。另一方面 ，OlaMake 结合实际的构建场景、构建任务所需的资源大小，还有触发构建的权限，来定义一个构建任务的优先级队列，实现自动调度优先任务。软件包构建系统的第3个能力是增量构建。我们分析了业界同类构建系统，它们的增量构建有一些缺点。首先是它们没有一个快照的概念，没有一个稳定的基线。第二个，它们没有全局的 catch， 没有中态一致性的这个约束。第三个就是它们不保留构建环境，那么构建结果的话就很难复现和回溯。那 OlaMake 是首先采用一个快照来确定每一次构建任务的基线信息，包括软件仓的 commit、构建依赖、构建机器和环境变量等等。在对当前快照，比如说这个 Snap2 和上一次快照 Snap1 之间的 commit 做一个差异，然后再去分析这些差异的反向依赖链，得到一个最终需要构建的所有软件包。那么在分批消费软件包构建任务的同时，生成一个同批次的一个历史 RPM repo， 并且作为下一批构建任务的依赖 repo。这样 OlaMake 在确保构建依赖不变、构建产物一致的前提下，就能够支持历史构建任务去可回溯、可重复，更方便这个问题的定位。软件包构建系统的第4个能力是一体化社区开发者本地测试和 CI/CD 门禁测试。我自己也是作为社区的开发者，那我认为现在的门禁有一些痛点。首先是首先是 PR 的门禁，它不支持远程的调试，那么必须依赖于我在本地手动去构造一个相似的一个环境，那么这样这样不方便也很低效。第二个问题是现有的社区 CI/CD 门禁在同架构下只有单机资源，这样的话时常会导致很多开发者提交的门禁的任务在排队，等待的时间比较长。第三个是现有的门禁它只支持单包构建验证，这样的话就没有办法帮助开发者去验证反向依赖是否受其影响。针对这几个问题 ，OlaMake 也是采取了几个措施。首先是 OlaMake 对外开放了本地构建和本地复现的 CLI， 这样支持开发者在本地可以一键复现和调试。第二个是 OlaMake 将自己用于版本工程构建的构建机资源共享给门禁的构建任务，这样可以大大的缓解门禁任务拥塞的情况。第三个 OlaMake 是实现了针对软件包的指定增量构建，指定增量构建就可以验证当前 PR 关联的软件包以及它的反向依赖包的构建是否是成功的。 软件包构建系统的第5个能力是通过支持 Lab 接入来实现社区开发者和社区伙伴的分布式协同。社区伙伴可以将自己实验室的机器接入到 Ola-Make 的构建机集群，然后借助 Ola-Make 的分布式任务调度和资源自动适配的能力，实现资源共享、共同构建和共同测试。那当前 Ola-Make 实际上已经接入了外部的 RISC-V、LongArc 和 PowerPC 64LE 的机器。这里展示了软件包构建系统主要的前端页面。从左边是首页，然后工程列表、工程概览、工程配置。左上角是工程构建历史，然后工程的用户管理。左下角是单包的概览，右边是单包的构建历史和 RPM 下载信息。这里展示了软件包构建系统某个工程的一次全量构建的 demo， 然后最上面是它本次全量构建启动的时间、构建的结果。下面的表格展示了本次构建任务中所有软件包的它的构建依赖、反向依赖，它的最近一次构建任务的启动时间、构建时长还有结果。下面的这个图展示了这次全量构建任务中所有软件包的一个构建依赖的可视化的图。右边这个是展示了本次全量构建任务中部分软件包它的一个构建状态的变化，还有每个软件包预估的构建时长。接下来我来介绍 Ola-Make 的全场景 OS 构建系统。它的功能板块主要是分层定制和镜像定制。从整体上看，大概分为6个部分。第一部分是用 YAML 来作为软件包构建描述语言的新格式，来支持软件包定制构建选项。第二个是提供一个新的公共 BaseOS 组织形式，包括若干 spec 转换生成的 YAML 文件，并且提供定制项。第三个是由社区伙伴在公共 BaseOS 基础之上，针对他们的行业场景、芯片和产品来定义一个定制层，并且支持可堆叠。第四个是由 Ola-Make 平台来提供统一的镜像定制工具。上面第5个是分层定制覆盖全场景，包括服务器、边缘云、云计算、嵌入式这些。最后一个是覆盖接入更多的多样性算力架构。这里展示了分层定制将 spec 中关于软件包的描述转换为 YAML。这里我们可以看到带有这种 Python 表达式的 YAML， 更简单也更灵活。这一页展示了分层定制将 spec 中关于软件包构建各个阶段的描述转换为 YAML， 转换为一个独立的 shell 脚本。那独立的 shell 脚本的话，是方便于编辑、自定义还有调试。这里展示了分层定制当前支持的所有的定制项，包括软件包的版本号、构建依赖、运行依赖、编译类型和编译选项等等。那分层定制最重要的一个特点就是允许用户像乐高一样定制一个自己需求的场景化 OS。这里 Ola-Make 在公共的 BaseOS 这一层基础之上提供了不同层的一个定制。比如说这里的一个芯片加速层，用户可以选择 Chipone 来加速 ROS 镜像。这里展示了分层定制的一个 demo， 左边是定制了 Redis， 然后重新构建生成 RPM 包。这里的定制包括了指定构建指定了编译器，构建选项，它的构建 prep 阶段的脚本，还有它的2进制子包的拆包的策略。右边是基于左边生成的 Redis 的新的2进制， 重新定制生成一个包含 Redis Server 的容器镜像。好，最后我来介绍 OlaMake 全场景 OS 定制的第二个定制能力——镜像定制。镜像定制的现在的需求来源主要是镜像瘦身，还有镜像安装之后无需部署开箱即用。那各行各业对于操作系统的要求是不一样的。OlaMake 提供一个简单灵活的镜像定制能力，允许用户可以自定义选择软件包来去进行定制适合自己场景的 OS。镜像定制的基本原理就是面向全场景的镜像格式，在定义一个镜像启动的最小的集合的基础之上，允许用户自己添加自己需要的软件，再执行制作脚本。目前 OlaMake 的镜像定制集成了2个定制工具，分别是 OEMaker 和 ImageTailor。OEMaker 主要是用于标准镜像的 RPM 力度的裁剪定制。ImageTailor 可以用于多种镜像格式的生成定制，可以允许用户去修改文件和配置项。这里展示了镜像定制的几种常用的场景。第一个是使用 OEMaker 基于一个已有的 OpenOla 的官方 repo 或者本地的 repo 来制作一个带有安装器的 ISO。第二个场景是使用 OEMaker 在 OpenOla 官方发布的一个 ISO 镜像的基础之上，允许用户去添加或者删除软件包，再重新做一个 ISO。第三个场景是使用 OEMaker，允许用户在修改它的 Kickstart 的示例文件的基础上来定制 ISO 的一个启动的过程。最后一个是使用 ImageTailor， 然后基于 OpenOla 官方 repo 源、本地 repo 源，还有本地的一些配置文件，然后重新生成一个场景化的 OS。第3章是介绍一下 OlaMake 现在的现状。目前介绍 OlaMake 的使用现状。OlaMake 现在在社区的工程分为2类，一类是个人工程，已经超过了1万，然后是版本工程，已经超过了100。现在它的注册用户已经超过了300，活跃用户也占了1半。第3个是它目前整个所有的构建任务的数量已经超过了190万。第二方面是OlaMake 在其他客户侧的一个部署，现在已经有2家客户在本地部署好了自用的OlaMake， 分别是超巨变和金山云。最后是介绍一下我们下一步要做什么。下一步我们主要做这几件事情。第一个是实现 OlaMake 的自动化部署，然后来帮助客户在本地部署他们自用的 OlaMake。第二个是与 OpenOla 社区的一个自动化测试流水线平台，也就是 Ola Pipeline 去合作，然后打造一个一体化的社区开发体验。第三个是实现一个外部 lab 的接入，然后支持社区伙伴的实验室的机器接入到我们这个统一构建平台上来。第四个是优化一下 OpenOla 现在公共基础 Base OS 的一个定制层。最后是针对目前用户反馈的一些前端使用的体验来优化。最后说一下关于 OlaMake 开源的一个情况。目前 OlaMake 前端的服务已经对于社区开放，然后代码仓源码仓也会在不久将来对全社区开放。好，谢谢大家。
Thank you very much. And yeah, I would like to have your colleague here on stage as well. So we'll have a short wrap up together about this session. Thank you very much.
Okay. First, I'm Warren from OpenOla community. I'm the member of technical community. So I want to make a supplement about, Shenjin's sharing about what is OlaMaker. So So what is OpenOLA? As Dr. Sean already said, we are an operating system for all scenarios. So as you know that in the server and the cloud scenario, I mean, we always use OBS. But the problem is that OBS cannot cover the scenario of embedded and edge, which require cross-compile, fine-grained customization. So this our current status is for server version and the cloud version, we use OBS and the similar mechanism to build it. But for embedded, and especially for embedded scenario, we are using Yocto. So we have idea why can't we unify them together? Just use one unified platform to build different OS for different scenarios. Because as we know that no matter server, cloud, embedded or edge, they are all Linux-based systems with a kernel, with package, with container, with image, right? So it's definitely we can use one mechanism or one platform to build it. But the status is that they are divided. So that's why we have the idea of Aura Maker. So this is a young project, and Senlin and my colleagues already did some initial work to improve the distributing compile of server OS. Well, the challenge of server OS is that for a server OS, it consists of thousands of packages, right? So it must be used, cloud native or distributed mechanism to build it in large scale, right? So this cannot be handled by embedded system like Yocto, because Yocto can build OS versions for example hundreds of packages, right? So that's why our current focus is on large scale distributed building. And when we've done this, and in the future we will try to extend Aura Maker to embedded scenario. For example, you just need to write the recipe or spec or YAML or whatever just once. Then okay, the build system will, according to your configuration, according to your need, to build different OS for different scenarios and according to your requirements. So this is the plan of Aura Maker. So and we think that as we know that there is no such a system in the world, as we know, right? So and the journey to make it happen will be long. So we hope that we just start Aura Maker, and we welcome more and more developers and users will join in to help us to making Aura Maker better and better. Okay, thank you.
谢谢大家。
Thank you very much. And as we are an international event, thank you. We would like to have a short wrap up here also in Vietnamese. So thank you very much. Yeah, please go ahead.
Như mọi người đã được nghe anh và hai người của bên OpenOLA của Huawei đã có bài diễn giải về OpenMarker là một hệ thống xây dựng gói phần mềm cho phép các nhà phát triển biên dịch mã nguồn thành gói phần mềm nhị phân và cho phép các nhà phát triển lắp ráp và tùy chỉnh hệ điều hành dựa trên các khối xây dựng theo từng kịch bản. Nó có thể cung cấp các khả năng xây dựng tăng dần toàn bộ, tùy chỉnh theo lớp và tùy chỉnh theo từng hình ảnh. Có ai có câu hỏi gì không ạ?
Okay, thank you very much. Yes. That's all for this session. So, and we move on. Yeah.
Okay.
So very helpful. These change. And I bring something here also.
Okay.
Yes. Next time we have this. Yes. Thank you very much. Yeah. Thank you for our translation team. Interpretation team. Interpretation. Yes. And we have the next talk coming up. I would like to ask Mr. Liang Li to come here and already set up his computer while I already share about Mr. Liang Li. Yeah, thank you very much for joining us already. So, Liang Li, a developer at Huawei Tech, specializes in the design and architecture of low-level software, including BSP. BSP stands for Board Support Package. Bootloaders and architecture-specific parts of the Linux kernel, with expertise spanning across x86, 64, ARM64 and RISC-V architectures, Liang's comprehensive knowledge base underpins his significant contributions to the field. Recently, his focus has shifted towards advancing virtualization technology and memory management areas, further enhancing his profile as a key player in the development of foundational technologies that drive modern computing systems. Thank you very much for joining us. And we're checking the microphone. Yes, does it work? Yeah, all good? Okay, perfect. So, big round of applause. Thank you for being here with us.
Good afternoon, everyone. Here I'm glad to share this topic about the new shared memory mechanism design. Here is my agenda. Start from the brief review of memory model basis and then share the memory system design and the brief demo, then discussion of the application scenarios. First of all, let's have a brief review of the memory model. In short, the memory model is a set of rules about for memory users about how to use memory. Generally, there are two kinds of memory users. One is hardware and another is the software. Hardware users are usually the processing elements, such as general purpose processors, accelerators, and ASICs, etc. General hardware users could any kinds of computing units that could issue memory access. From hardware's point of view, they would particularly consider the memory hierarchy and the memory attributes. Also, the memory order and atomic semantics abilities are also interested. From software designers' point of view, the memory model is mainly about the memory ability that being presented to programmers. So software designers cares about the points like how does the memory being organized in flat or sparse mode. Does the virtual address, does the virtual memory architecture is enabled in a segment mode or the paging mode? And moreover, does the memory model support different access ordering and different atomic semantics to support software mechanisms like the different locks and all the lockless software abilities? Consider the multiple users of a memory system. We actually extend the single user memory model to shared memory model. As a software designer, the particularly cares about the memory model is something tricky on the cacheable or bufferable points of the memory system. Software mechanism need to some special efforts to take care of these hardware abilities to make sure the software can be running in a predictable behavior. Sorry. Sorry, my slide is a little out of date, so I'll jump to correct page. Here, we just take the memory pool as an example. We would discuss some aspects of the memory pool on this memory model basis, such as does the memory pools support the caching or the buffering does the memory pool support which kind of data caching, and how many operations could be buffered at a different place? And if the caching is enabled, will the cache coherence be implemented by hardware or by software? It's all about a memory pool needed to care about. And some advanced points like the atomic ability and the data consistency assurance and access orders for the memory pool. It's a big problem for memory pool software. And before we jump into the software, shared memory software for memory pool, I'll just review some existing shared memory mechanisms in Linux system. The first one is the System 5 shared memory design. Each shared memory region in the System 5 shared memory system is represented by a unique key. The user process could use the shared memory attached to map the shared memory region into their address space based on the unique key. And after attach, the user could gain the access control to the shared region if the user has proper access privileges. And if the user has finished the data consumed, it will have to call share memory detach and share memory control since library interfaces to control the shared resource. In a real user application, if the application needed to use the shared memory region to exchange data between its tasks, there are two additional important mechanisms is also needed. One is the communication channel that distribute this case for the memory segment to tasks. And the second one is the synchronization mechanism for the real workload to force the sequence of the use case for the shared resource. These two mechanisms is not contained natively in shared memory system. And a second mechanism I want to review it here is the memory file descriptor design in Linux. As its name indicated, each shared memory region in MemoryFD has a memory file as a backend in the memory, but the memory file has no file system entry, just anonymous file in memory, so there's no content on the persistent storage. The shared region is represented by a file descriptor. This enabled file descriptor-based operations like read, write, and map, etc. And one notable feature of the MemFD is the sealing and unsealing state of a memory file. Once the file is sealed, the corresponding memory region is in a state like it cannot be accessed in some certain cases. It will just being accessed after the on sale. And there's some just like the System 5 shared memory, the memory file descriptor based shared memory is not system-wide to all user process. It's just the nature of the file descriptor. It's kind of a per process resource, so it has more security benefits compared to System 5 shared memory, and on the two aspects I just mentioned in the communication channel for distributor file descriptors and synchronize mechanisms for different users of the memory file descriptor, the MFD and the System 5 shared memory was on the same line. They just both lack of such kind of ability. So next, I'll present our design shared memory system for memory pool. First, we introduced a kernel module, just the MP-SHAM kernel module to provide the interface for libraries. It provides the I/O control interface for users. Issue the share memory create or delete option to create and remove the region accordingly. And one notable option at the creation of a shared memory region in our design is the global shared memory cache coherence option. That means if this option is specified at the creation time of the shared region, all users subsequently of all subsequent users of this shared memory region must in the same cache coherence domain. In short, the cache coherence domain it means all users will have a local copy or local cache for the shared data. But these local copies can be maintained by the hardware or by the software to keep these copies in a consistent way that for the memory pool shared memory system. This option means for MP-SHAM mechanisms, it won't care about the coherence abilities, just offload the responsibility to some other module. And once let's consider some use scenarios like the shared memory region is reside in the memory pool. The different users, such as different architecture systems like ARM system or some RISC-V system, will share data from the memory pool. So if the different, as I just said, different computing systems almost define its own memory model, and clearly the different architecture will have different memory models. So the single system memory, shared memory mechanism like MemFD or the System 5 shared memory won't suitable for this scenario. So if that's why we have this new memory pool shared shared memory system, and we provide two important options set here. The first one is the DMC command, which stands for data cache maintenance. And another one is the GK option. GK option stands for the gatekeeper. The data cache maintenance option means the MP-SHAM will take care of the cache and the cache coherency abilities. And the GK option means that it's similar to the seal and unseal option of the MemFD design. It just means after the GK, which stands for gatekeeper, the users of the data will give up the access rights to the shared region. Let's take an example. The code blocks on this page simply abstract a use scenario of an application. It starts from MP-SHAM attached to some shared region. Then in the worker function, it will produce or consume data within the shared region. After the work done, call MP-SHAM detach interface to give up the access rights. It will do this cyclically in a loop. And just as the comments in the pseudocode, there are two data maintenance and gatekeep sub-functions was invoked on behalf of the MP-SHAM detach function. Okay. Just one slide. Actually, this is a high-level abstraction of the working load for the user scenario of our shared memory system. And next, with on this page, we can see that the interface design of our system is not compatible with the existing applications. So, for a memory pool scenario, there's a certain existing workloads such as the large-scale database systems and big data applications, and some cloud applications, which would potentially have benefits from the memory pool scenario, could be worth to be modified to adjust the MP-SHAM abilities to maybe these applications can be benefits from the memory pool. It also worth to add the native support into operating systems shared memory mechanism to natively enable the OpenOLA to be ready for these memory pool systems. That's all my sharing today. Thanks for listening.
Yeah,
Thank you
very much. And yeah, please stay here while we have the short wrap-up in Vietnamese about this talk. So definitely appreciate it, and we would like also to share some thing in Vietnamese.
Okay.
Okay,
Bài diễn
thank
thuyết
you.
vừa rồi của ông Lý Liang, developer của Huawei Tech, đã nói về hệ thống quản lý bộ nhớ của hệ điều hành đơn. Hệ thống này thường dựa trên mô hình bộ nhớ chuyên biệt được xác định bởi ISA của CPU. Mô hình bộ nhớ cụ thể sẽ liên quan đến việc xác định phân cấp bộ nhớ, thứ tự và tính nhất quán. Sau đó, trình quản lý bộ nhớ sẽ được xây dựng dựa trên những cơ sở này. Bài diễn thuyết hôm nay đã thảo luận về những thách thức và cơ hội khi thiết kế một hệ thống bộ nhớ chia sẻ hiệu quả cho mô hình bộ nhớ mới với một số loại phân cấp, thứ tự và nguyên tử mới ạ.
Thank you very much. Cảm ơn. Okay, so now we're getting ready for the next session. Yes, please come here on stage, Mr. Wei Jiang Gang, or Wei Jiang Gang, yeah?
Yeah.
Okay. Yeah. I'm always very happy when I get it right. So, yeah, while you prepare already, I would like to share some key facts about you. Wei Jiang Gang, with over a decade of expertise in technical development and project management, currently holds the position of senior manager at Jiangsu Hopron Software. His vast experiences encompasses a broad range of foundational software fields, including Linux OS, virtualization, cloud computing, automotive electronics, for example, AutoSAR, HPC supercomputing, and artificial intelligence. Wei has made significant contributions to various open source software communities, such as the kernel KDump, LTP, QEMU, libvirt, OpenStack, and OpenEuler, showcasing his commitment to the advancement of open source technology. In addition to his professional achievements, Wei is actively involved in the OpenEuler community as a member of the OpenEuler user committee, where he continues to influence the development and adoption of open source solutions. Thank you very much for joining us here on stage. Please go ahead. Thank you.
Okay, thank you. Hello everyone, I'm Wei Jiangang from China. It is a bit late, it is a bit now. Thanks for your patience. I have been working on open source software more than 10 years. I was used to be a maintainer of Avocado project, which is a very famous test framework around the world and supported by Red Hat. And now I'm spending more time on OpenEuler community, and as I'm a member of OpenEuler user committee. Today I want to share a new technology. We call it distributed soft bus, and we can share the computing power and the data by it. Okay, let's get started. I will follow this contest to introduce this technology. In January, the Linux platform provides the most basically communication technology. But this technology, traditional IPC mechanism, only provides the basic capability and they are not friendly to the end user. Such an example, the pipe can only be in half-bit duplex mode, and the single is a way to head the ascending event. The shared memory supports transfer the largest amount of data, but it requires the same four to work together. So if we want to share computing power and data, depends on reliable communication mechanism. Of course, we have some new technology such as deep bus, but it also has its disadvantage, such as it is suitable for the graphic user interface, but it's not suitable for data transmission, and it has multiple vulnerabilities, and such as U-bus. So what we need is not only the IPC technology, but also the cross-platform and feature-rich middleware framework. This page, I want to talk about the orange, the distributed soft bus. We all know the hardware bus in microcomputer, right? It's the hardware bus comprises the CPU, memory, and other peripherals together, and it transfers the data and control the information is passed on this hardware bus. And the hardware bus has very typical features such as plug and play, high band ones, and so on. So we get inspiration from the hardware bus. So we decide and develop the distributed soft bus. We want to build an invisible channel between the different devices with different protocols and with different transmission rates. Okay, in fact, we have a big plan. We plan to develop ecosystem intention based on the distributed bus. The distributed bus masks the difference of the different protocols and different devices. Now the soft bus supports the internet, Wi-Fi, WiFi, Bluetooth, and other protocols. Based on the distributed soft bus, we develop connection of distributed components such as the distributed data, distributed field, and based on this layer, we develop some scenario-based distributed service and mechanism such as remote control and data sharing. So the end user can use the distributed capability, the uppermost layer, to develop their own application. It's very convenient. This page shows the design and the architecture of the distributed bus. At the bottom, we can see the soft bus needs the bond driver in kernel. Based on the kernel's layer, the middle layer shows the soft bus the most core functions such as topo management and authentication, messaging, and the data transmission, and other very important features, service management, and so on. The upper layer, we provide some higher level functions. At the right, I give an example about the calculator, about the distributed camera. At the outside the open Euler exhibition area, I give another example for the distributed calculator. If you have interest, you can experience it by yourself. This page, I want to talk about the innovation brought by the distributed soft bus. In general, if we want to develop an application, in general, we should create the socket, both the connect end and the server end, and then we can bond and listening to the ports at the server end, right? And then we repeat the circles of sending and receiving. It looks more complex and yeah, it's not convenient. So let's look at the distributed. If you use the distributed bus to develop your own application, in this way, the registering and the callback is a very important mechanism. We can register the function and listener on the server end, and when if there's data from the connect end, the server end will call the callback function to process these data. So it's very inconvenient and cost the users work done. This is an example I just mentioned last second. You can experience at the Open Euler exhibition area. The mathematical expressions can select the suitable device to calculate, yeah, right? According the mathematical expressions complexities, at the bottom layer we use the distributed bus, and based on distributed bus we use the distributed data subsystem to support the distributed collaboration. Yeah. This is an example. This is a video to show that example. Okay, let's play. You can see the mathematical expressions. Yeah, it's a collaborative case, and you can operate it by yourself and the Open Euler exhibition area. And last, I want to talk about the next plan and invitations. We want to support more protocols, such as the industry protocols, and increase the maximum of device connections. The value is 20 now. And we want more distributed soft bus can be run on different Linux distribution, such as Ubuntu and CentOS and so on, and other distributions. And we hope more programs know this technology and use and contribute to distributed soft bus. I post the main page of Open Euler. If you have any interest on this technology, please join us. Okay, that's all. Thank you.
Okay, thank you very much. And we have the translation, the wrap up in Vietnamese. Yes.
Bài diễn thuyết vừa rồi đến từ diễn giả là giám đốc sản phẩm của công ty trách nhiệm hữu hạn phần mềm Home Run của tỉnh Giang Tô. Trong bài diễn thuyết, diễn giả đã giới thiệu nguồn gốc và chức năng đặc trưng của Softbus phân tán, trong đó có đề cập đến khái niệm bus phần cứng máy tính. Dựa trên Softbus, các dịch vụ phân tán như ảo hóa thiết bị, cuộc gọi dịch vụ đa thiết bị cũng như cộng tác đa màn hình và chia sẻ tệp đều được thực hiện. Diễn giả đã lấy Open Euler và Open Harmony làm ví dụ. Bài diễn thuyết đã giới thiệu cách triển khai dữ liệu phân tán, tệp phân tán và ứng dụng phân tán dựa trên Softbus phân tán, giới thiệu các trường hợp ứng dụng của bus phần mềm trong phân tán ở tài chính, an ninh và các lĩnh vực khác.
Okay, thank you very much. Yeah, so we're nearly at the end. Just want to check, are there any questions? Any questions? Please let me know. Question there? No? No specific questions, but like you can always go to the Open Euler booth And I would like to remind you, could you translate this please for me to Vietnamese? So you had the chance now to learn about the technologies. There are a lot of opportunities also for the coding programs at Open EULA where you can participate and earn up to 42 million Vietnamese dong over the summer. So please go to the Open Euler booth and inquire about these opportunities and discuss this with the developers here directly at the booth.
Nếu mọi người có bất kỳ câu hỏi nào hay là muốn tìm hiểu thêm về các phần mềm của Open Euler của tập đoàn Huawei thì mọi người có thể đi ra ngoài và đi sang phía bên trái của hội trường, thì mình có thể vào trong booth của Open Euler và sẽ được nghe giới thiệu chi tiết thêm hơn nữa về các thiết bị cũng như các phần mềm mà bên Open Euler đã lập trình. Cảm ơn tất cả mọi người ạ.
Okay, thank you very much. And I would like to give a big round of applause for the entire track of Open EULA and for you and everyone else here in this track. Thank you very much. Thank you. Okay, and we now have the break. So there's a 30 minutes break. You can get some refreshments outside, and in 30 minutes we continue with more topics on operating systems. Thank you. Good. So, yeah, people are still streaming in, but guys, we are already starting here. Need to keep to the time, and there's a lot to share. We have like very interesting talks coming up. And at first, I would like to welcome Sayan Chowdhury. Sayan, you have quite an impressive bio, and I would like to share a bit about you first. He's a senior software engineer at Microsoft and a Linux software engineer indeed, and a maintainer of Flatcar Container Linux. As a release manager, he works to maintain and build Flatcar with a strong passion for open source. And that's absolutely true because no open source engagement for many years. Sayan has been involved in other communities, namely Python, Fedora, and Mozilla. And he is a PSF fellow and former chair of PyCon India 2020. And PyCon India is like a huge event, right? So we are kind of a small event compared to PyCon India.
Not at all.
Okay, but PyCon India is huge indeed. So that must have been an amazing deed to do that. So yeah, and he fosters community engagement and provides mentorship to aspiring open source contributors. So if you're interested, maybe show your interest to Sayan. He might be able to help you and give you some advice and mentor you. Beyond technology, he's an artist, enjoys bouldering, treks and photography. Yeah, just very interesting what I read about you all the time. So thank you very much for joining us. We're very much looking forward to your talk. Thank you, Sayan.
Thank you. Thank you, Mario, for the introduction. So good afternoon, everyone. Hope you had a good break and had some tea, coffee before the talk. So let me start with the talk now. So my topic is, so you want to run containers, but which OS do you want to run it on? So this is, we have seen an uptake in the number of people using the whole container ecosystem with Kubernetes, Docker in the picture. And there has been a strong focus on the OS side as well on to make things better for this whole ecosystem and support the ecosystem of containers. So moving on, so the agenda of the talk is, so I'll be having a 25-minute talk, and I'll be giving my intro at the beginning, and then we will discuss on why we need a container OS, why there is a need for container-focused OS. Then moving on, so if you have read my CFP, there I submitted that this container OS focuses on 4 pillars, which are minimalism, speed, security, and immutability. Now, once I cover all these 4 items, and then I'll give you a brief introduction on a few of the existing container OSs out there. And after that, on how you can take how you can use this talk as a leveraging point to decide which OS you would like to pick up for your next container workload. And then finally, I'll give a brief introduction of Flatcar Container Linux. That's a project I work on a day-to-day life. I've been associated with it for 4 years now, and I'll definitely love to give a brief introduction about it so that you can use it for your next workload. And finally, a few rounds of questions. I would love to hear what are your thoughts, any feedback, or any questions you have for the talk. Cool. So moving. Hi, I'm Sain Chaudhary. I am from India. I work for Microsoft, and I'm based out of Bangalore in India and have been working for the Flatcar team for the past 4 years now. So just to give a small history, so Flatcar was initially spawned in this company called Kinfolk, which was later acquired by Microsoft in 2021. And that's how we ended up being at Microsoft and building this amazing OS with more better support from the company. And we are essentially under the Azure umbrella. And we try to, even if you have any questions about Azure, you'd feel free to contact me after this talk. So the 4 pillars. So what is a container-focused OS? So we essentially have the focus areas, if you see, are targeted for 4 pillars, which is minimalism. It focuses on how minimal we can keep it. Then the next is speeds, security, and immutability. I'll go through them one by one. But before that, why do we even need a container OS? Now, the thing is, like, if you have worked in the DevOps space, then in the recent times, you have seen that the space is widely divided into 2 categories. One is the mutable infrastructure, and the other is the immutable infrastructure. Now, what is a mutable infrastructure? So the mutable infrastructure means that you have your setup, you have your servers. If there are things that are going wrong, you basically what you can do is that you SSH into the server and then quickly edit things or update your configs or restart machines or have a touch with the servers wherever and whenever you need. Whereas in an immutable infrastructure, the idea here is that you try to break and if things break, you try to you basically try to kill that particular server and spawn it up again. And it should be in the same state as the previous one. So in case, suppose your OS breaks, so what you can do is that you can maybe update the base image and then spawn up a new instance immediately with the updated configs. Now, why do we need this? The reason is with the is in my next slide, which is cattle, not pets. So this has been a very a term that has been going on for ages now in the container ecosystem, where we treat our the basic, just to give an example or to understand this in a much finer details, is that when you have a pet, you take care of it, you give a more, you have a name for your pet, you take, if there is some illness to the pet, you take care of it, take it to the vet and take care of it, love it, give it some care. Whereas in terms of cattle, you have, if you have seen a cattle farm, they are particularly numbered, maybe they are by categorized by breed, or and they are doing just the job they have to do. So if this is taken into the perspective of infrastructure, so pets are basically servers which may be contained in a mutable infrastructure, whereas in cattle you have your servers grouped by their categories. Suppose you have a database cluster or your web cluster or your backend cluster, and then whenever there is some issue, you don't really cater to their needs. If there's something wrong, you just kill that particular machine and spawn a new machine up. So that's the ideology that has been going in the microservices space with the container ecosystem, that just so that we can have faster deployments, you have much more reliability, and it's easier to debug issues in case things go wrong. And yeah, so this is where the container OS comes into picture, because it aids you to build up a system that can support the life cycle that you have for your apps. Now, now going into what is a container-focused OS. So the first topic is minimalism. So with the minimalism part, we are seeing here three primary aspects. One is a minimal package set, the second is minimal human interaction, and third is minimal resources. So what we are targeting here is with the OS that you have, so essentially suppose there is a container OS, most of the container OSs don't have a package manager inside them. So you are limited to the packages that are provided by the OS that you are using. And they are usually small, as in you have only the minimal packages that are required inside of the OS, and that can, depending on what are the OS goals, which OS are you using, that can be from few OS have lesser than the required, few have more, but it all depends on the goal that the OS has. But all of them would have a very small set of packages which is required for the containers to run. The next is minimal human interaction. So as I mentioned, like we try to build a cater to build a immutable infrastructure where you as a person would not require to SSH into the machine. There are a few OSs which actually restrict to do so, and others have the option to SSH, but then at the end of the day we want you to tear down machines and if required spin up a new machine with updated versions or updated packages, or if your apps are getting upgraded, you tear down the machine and build up a new one. And then finally, minimal resources. With lesser number of packages, you end up having lesser resources being used, and more of the resources can be used by the apps that you are working with. The next is speed. So with speed, we have faster deployments. Then you have optimized for container workloads and boot speed. So given you are essentially tearing down, so whenever the boot speed, whenever you're booting up a new machine, it would be ready in a few minutes, or actually seconds, so to speak. Now, this is because there is a less overhead, there's a less dependency chain involved during the boot process. So you would see a tangible reduction in your deployments. They would be accessible or be available in a lesser span of time. And then because this is, our focus is only for containers, so you would see that most of them are very highly optimized for all your container workloads, be it like all the tuning has been done for Docker or Podman, whichever container runtime you're using, or if you're using an engine like Kubernetes, it would be definitely be very highly paired up and in tuned with the Kubernetes releases, so that you get a much better performance at the end of the day. The next is security. Now, among all these 4 points, one of the biggest point that every OS puts a focus on is security, because given the number of CVs are getting released on a daily manner, the security leaks that are happening around the world, security takes a very high center stage, and you will see this has a lot of points in it. So one factor comes is immutability. That's something I'll discuss at the end, but then the next is automatic updates. For example, every OS has a different implementation. Some do AB updates, some do some other kind of update mechanism, but all of the OS have the option that whenever there is a new release by upstream, they would end up giving a signal, or the payload is directly uploaded, and then all the OS that all the machines that on a particular version would be automatically updated, so that you have the highest or the latest patch versions on your infrastructure for the machines. The next point is reducing the attack surface. This essentially happens because when you have a lesser number of packages in your OS, essentially we have a lesser attack surface. The reason is there are lesser packages that would have faulty areas, and also because this is immutable, we see a sharper drop in the number of CVs that we need to attend to. Now, this is one of the target areas for most of the container OSs, that they keep this small so that your infrastructure is usually more secure than the normal traditional OSs like suppose Ubuntu, Fedora, or others. Now, one thing I noticed while building this talk was that I actually gave a similar talk in 2019, the last FOSS I came to, and it was for desktop. Now I saw that the points which I mentioned was these three last points were kind of the same thing I mentioned in my previous talk, because if you categorize container OSs, they can be broadly divided. I'm talking about infrastructure here, but it can be broadly divided into desktop as well. There are a few desktop container OSs as well, which you can use your day-to-day laptop on that. And finally, then you have the secure container runtime, as I mentioned, with the in-tuning happening for the various container runtimes. We try to have the latest container runtimes in all our with the container OSs. And finally, the principal least privilege maintaining, so that whichever services or users, whichever access that is required, they only have that access or ACS. And finally is immutability. So in immutability, as I mentioned, there is no individual package management. We highly focus that you run your container workloads. Anything you need is driven through a container backend. And then, but you cannot really install anything on any of these container OSs. A lot of them have their root file system read-only, or for us, like it's a USR that is read-only, so that you can really not alter anything inside the root file system, which again increases the security of the OS overall. And then during the updates, whenever there is a new update, it automatically updates. But what if there is an issue? Suppose something broke down in between. So what do you do in that case? So it has, most of the OSs have atomic rollbacks and updates. So it tries to update the OS, and if there's a failure mode, it is done by a different, all the OSs approach it in different manners, but at the end of the day, the result is that if something fails, it would re-roll back to the previous version, the stable version, and then you would not even see a thing. Suppose there's an update on a Friday evening, you would, if there's a breakage, you would even see a thing, and it would update to either the next stable version, or if something fails, it would re-roll back to the previous one. Single version identifier. Now, so for example, in Flatcar, so we really don't have multiple versions. At any given point of time, it would be only one version that is getting attested. So we have an epoch time for when CoreOS started their first release, which was July 1st, 2013. Since then, we have been doing various releases. So each of them have like a single version identifier. So each OS would just pinpoint to one version. And then with the immutability, one great factor is it again reduces a lot of attacks. Like in 2019, we had a RunC vulnerability, which was totally not affecting the container OSs because the way how it operates, and immutability was one big factor there. Now, coming down to the OSs that are there in the market. So as I mentioned, we have Flatcar, which I'm part of. You have Talos, we have Fedora CoreOS, we have MicroOS, we have BottleRocket, and we have Photon. Now, these are the few container OSs that are out there, and people use it on a daily manner. But they are architecturally very different, though they imply all the fundamentals that I discussed now, the minimalism, security, speed. But how they implement is different. So just to give you an example, so Flatcar has this release policy of maintaining 3 channels, which is alpha, beta, stable, whereas Fedora CoreOS does it via streams, which is a testing stream, and then they have a production stream. Or for example, suppose you have the provisioning can be, so Flatcar, Fedora CoreOS, these all use provisioning agent called, like there's a software called Ignition. So we use that, but some other OS would use a different mechanism. Then for Flatcar, you would need to you have the like the USR is locked down, but then for others you would have the root side system locked down as well. And then there are a few OSs which have SSH also blocked, so you cannot really SSH in. Like for example, Talos here is very interesting because you have an API to manage your workloads as well here. Now, how to choose? So what I would suggest is that in case if you're choosing a new container ecosystem, in that scenario, first thing you should look into is the configurability. So how you configure your system. So suppose the thing that I mentioned is, suppose you need to update your, so suppose you use Cloud Init or suppose as Ignition. So you are limited by the options that you have, but they are usually like Fedora CoreOS and Flatcar uses Ignition, and we contribute to Ignition together to make it better. So in that scenario, you would need to change on how you provision your machine or how you attend to your configuration so that you choose a good OS. Then comes the security on how locked down you want your system to be or how free you want your system to be. That becomes a challenging aspect as well. So you basically pick up you do probably your analysis on your current setup and see which how much of a security need is for you. If you want your SSH totally locked down, then probably you would choose from one of these OSs. Not sure what happened here, but yeah. So you could probably choose from one of these OSs, and then finally is immutability. Immutability is probably same for all of them, but that becomes a factor because if you need to update things, like for Flatcar, when you do Ignition, it's just on the first boot that runs and applies a config. But if there are other OSs which gives you option to append things later, then that could be also be added to your choice. Continue? Yeah. Okay. So yeah. So as I mentioned, as I work with the Flatcar Container Linux team, so I wanted to give a small introduction about Flatcar Container Linux. So it's an OS that was spawned out of, it was forked out of by Kinfolk, forked out of Container Linux, which was maintained by CoreOS, and then after it been AUL, we have implemented a lot of features in there. We actually quite went side stream, and the way we see things or the kind of the architecture what Container Linux has been totally changed to what Flatcar has. Like we are working on to build system extension and other features as well. Then you have the releases, which happens at a monthly cadence right now, but if required, if there are security patches, we increase the cadence to bi-weekly sometimes, but we have technically alpha, beta, and stable. Alpha is probably released every few weeks, and then beta at a more bigger cadence. We try to soak things, and then finally stable. Stables are one of the ones which has a lot of features going at once. And then we maintain a 18-month cycle for LTS. We release every year, but the support cycle stays there for 18 months. So yeah, and this was a requirement because with LTS, you try to find some stability there. So this also becomes a choice, like if you want more stability. So LTS, Flatcar LTS becomes a good choice for you. And next is provisioning. So the provisioning for Flatcar happens through Ignition, and it's a first-time boot only thing. So you have Butane and Ignition working in parallel. So you can have configs, which actually helps you. It's a provisioning agent, so you can really set up your system and then reuse it again and again to have the same system at the end of the day. And then on the immutability and security aspect, so we tend to like our security cadence is we give a very high focus to security. So we try to have a very high cadence for any of the security fixes that are or the CVEs are released, and we try to do a release whenever there is very high maintenance security that needs to be taken care of. And the last one is, it's got messed up, but the availability on the cloud providers. So we have a lot of cloud providers that we support, and we keep on adding more and more cloud providers every day. You could see Flatcar on DigitalOcean. So we have a server where we host all of our images if they're not on Marketplace. So you can take those images and upload them to the cloud providers. But if they're on Marketplace, we are there on like the Azure Marketplace, we are there on GCP, we are there on AWS, and more that we have been working on. We recently, I guess we added the Brightbox. And the other thing is, the last thing I would talk is about the community, because it's an open source project, and it's growing day by day. We have, if you're looking to contribute, so we have open office hours every month, and it's on the 2nd of Wednesday, and a developer sync meeting that happens so that you can directly interact with your developers. With the developers on the team, and these are to cater to any of the needs that the community is having. And if you're looking to contribute, we are available on Matrix, where you can directly talk with us. So just to give you a list of the things that we have. So the flatcar.org releases shows all the releases. You can just go to flatcar.org, which would have all the information for you. And the GitHub repo is flatcar/flatcar. Documentation is there on Flatcar docs. And we actually built a tutorial because the whole container OS concept is pretty new. So we built a tutorial around it, which is a 4-step process, and you could read it through and follow it on your local machine, which is Flatcar tutorials. And then finally, our communication channels are, we do office hours or our Flatcar Jitsi server. So every month on 2nd Wednesday we meet. You could find it on GitHub discussions, and then we are there on the Flatcar Matrix. If you have any issues, you can directly drop on that channel. We are also there on Kubernetes Slacks, is Pound Flatcar. And if you have any questions related to Flatcar, you can directly jump in there. So now time for questions. We have time for questions? Or any questions that we have?
I experience a bit. I experience a bit. The people are a little bit shy in the big hall to ask the questions, but I got a question there from the back.
Sure.
And somebody said they saw this slide from you with immutability, and they weren't very clear what it actually means. And if you could explain this very shortly. Yeah?
That's a very good question.
Maybe I don't know if you can go back to the slide. Yeah.
Oops. So that's a very good question, actually. The question was, what is immutability? So in plain English words, immutable, when you refer in computer science, is usually something which cannot be changed. So if something, suppose in the programming constructs, if you have any item or any type that is immutable, you cannot really change it. So immutably in OS aspect is like things are locked down in a lockdown mode or in a read-only mode, so that you cannot really alter it even if the user wants to. So the reason for this is that so that we increase the security aspect of the container OS so that your container workloads are more secure. And this is actually done through all the points that are mentioned here, which is like having no package manager, having a root system lockdown, or like having atomic rollback so that you have lesser control on the actual Linux host. And if you need to alter things, you go to the provisioning state and then change your configs and then upload boot up a new instance. You cannot really, the reason for Ignition became having first boot only is the reason that you cannot really alter things. Any more questions?
Yes, there's one question here.
Usage of Docker images is often at, how to say, a transitive issue. Most of the usage is not going back to the original OS, but start from whatever image there is. How do you plan to deal with that, right? I mean, if you have a Python application running, you pull from Python and they run on Debian, right? So you pull Python Slim or whatever, yeah. So you get what they use, and that's not optimal. Have you any plans to work in this direction?
So just to understand your question, so you're meaning like if there are issues that are more from the container or the Docker side?
No. This is independent of Docker or Podman. It's right purely from the Docker image. Okay. Most of the Docker image we use in daily life are not, we don't start from the OS, we start from a specific image, for example, for Go, for Rust, for Python, for whatever. And by this transitively use what the Rust developers, the Go developers, whatever, decided as their base OS for the Docker, for the Docker image, right? So there is often not for us to choose a different operating system because we would have to go through a lot of stops and setting it up. So that's the question, if you have any ideas on how to deal with that.
So the question is primarily that a lot of times when you're deploying your workloads, then if you have an OS, but then when you're working on Docker, you really don't have a lot of control on the image that is you are getting from the upstream, right? So in this scenario, I would say like we really don't have much control on that manner. We would probably recommend you to build up your own OS image in that, your own Docker image or any container image in that sense. But we don't really have much control over that sense because there are issues which we, like when we release an OS, whenever there is a stable release, we do see a lot of uptake on the number of issues that are getting reported. But there are a lot of times those bugs are probably coming from the Docker images as well, so we don't really have much control in there. We probably would we probably would help with working with the Docker folks to fix that issue if that issue is there with tinkering with the OS. But then, yeah, if there are security loopholes or like if there are issues which are suppose there's fraudulent mirror or something, we cannot really help there.
Yeah, so as an example, I would be more than happy to have a Docker image with unmutable root and user file system and Python already installed, right? A system that is locked down but provides me a Python environment. So these are the things where you might, on your side, provide these kind of base images for certain programming languages based on lockdown, user root, different changes, like whatever.
Right. So one thing that comes to my mind is that we are working on this new technology that Systemd is bringing in, is Systemd system extensions, and we are on the way to implement. So this helps to build your own images on top of those, because the OS root file system is locked down, so this gives a better control on, you can create your own images. And in that scenario, we also provide our own images as well. So this is where we can provide our maybe an NVIDIA image or a Python image so that people can consume those and work with those instead of like working with the upstream ones. Yeah, I think that could be one of the solutions there.
Thanks a lot.
Yeah, thank you.
Okay, so yeah, I think there are more questions, but we unfortunately don't have time anymore. Yeah, the next session is up, but Sayan, are you available here, like also afterwards? Are you out in the hallway track and people can come to you and ask you more questions a bit? Yeah.
Yes, so if you're interested in anything about containers, Container OS, or Azure, definitely find me in the hallway track. I'm mostly in the ground floor, so feel free to contact me, or my Twitter handle is Yudoka, or you can contact me on my email, which is gmail@yudoka.in. So yeah,
perfect.
Thank you everyone for coming to my talk.
Yeah.
And thank you, Mario.
Thank you very much. Yeah. Okay, so we just have a 2 minutes break to set up the next person here. So talk about the practice of developing SOGO input method on OpenKylin. Okay, so we are ready here, and yeah, I'm very glad to welcome Mao Zhou with the practice of developing SOGO input method on OpenKylin. Let me share a few key facts about Mao Zhou. Mao Zhou is a member of the OpenKylin Technical Committee, OpenKylin Community, and yeah, Mao Zhou is also a member of the technical community in the infrastructure SIG and packaging SIG. With a prolonged engagement in operating system software research, he has authored and presented several papers related to operating systems at international conferences. Sorry, and yeah, for example, ICACTE and SEAI, and he has additionally obtained multiple software copyrights and inventions. So thank you very much for joining us here today with the talk on OpenKylin. Thank you very much and welcome.
Good afternoon, everyone. Today, I'm excited to share with you our journey and experience in depending the SOGO input method on OpenKylin. First, let me introduce myself. My name is Zhou Mao. I'm the OpenKylin Technic Committee member and packaging SIG maintainer. OpenKylin community is an open source community founded by many people from different places and aims to build an easy-to-use desktop operating system. This image on the right, shows the UI of the OpenKylin, which has the desktop and tablet modes and support running on x86 ARM RISC architecture. And below is our homepage. You can go there for more information. This is our main platform architecture, from source code to package compilation, to image generation and unit testing. Doc management and translation management are also connected with our Git repo. We try to automate the process as much as possible, including automatic code uploading and automatic testing of daily image. SOGO input method is really popular, not just in China, but all over the world. The main job of the input solution SIG is to develop and keep up with the SOGO input method software and to release its community version. Mostly the folks from Shanghai Taoyuan community complaint team who maintains the input solution SIG. Moving forward, OpenKylin's input solution SIG plans to share more with the open source community, especially in data tools and secondary development. We stick to a simple approach, focus on tech, and always put the user first. This way, we make sure our input solutions are easy and smart to use. We are the go-to team for Linux input solution, trusted by many businesses across the different fields, like insurance, government, and public security. Our goal is to keep making things that meet the real-world needs of our users. Input Solution SIG has also obtained a number of certifications and certificates, such as AAA graded enterprise, 5-star service certification certificate, ISO 271 information security management system certificate, ISO 20000 information technology management system certificate, and so on. Let's talk about the next generation of SOGO input method based on the cross-platform input system PICE. This new version includes several import modules. The engine service module ensures our input method is fast and reliable. The keystroke flow module captures your typing efficiently. The panel system module allows for customization and support various plugins. Lastly, front-end module connect everything and make sure the input method works smoothly across different platforms and devices. Our focus is to provide flexibility through engine plugins and to ensure that SOGO input methods are easily adapt to any platform. This makes typing more convenient, no matter where you are or what device you're using. SOGO input method engine service currently supports Swift, Dbus, and another service, and can be customized and extended. Each service module supports both independent service process or process inlays. Multi-language and multi-module input functions can be extended by engine plugins such as national standard, minority language input, and remote character input, and so on. UI plugins for SOGO input method include handwriting pad, function key buttons, letter buttons, and more. Its callback modules include fixed file, input engine, key flow, and so on. SOGO input method is the first commercial input method adapted based on fixed file, and some problems were encountered during the adaptation process. Currently, fixed file is based on one of two even loops, libdbus and libsystemdbus. Different even loops are enabled in input method framework, depending on current system compilation environment. As a plugin for fix is need to consistent with the event loops of fixed file. Otherwise, it cannot receive signals. Another problem is fixed file version different, caused by function differences is different. The interface of fixed file has been changed in the high version, which lead to errors in compilation. It can be resolved by changing the parameters of the interface. Here is a demo of SOGO input method for open coding risk. It's sure you can type in many languages using SOGO on Open Coding Risk OS. There are also some problems with adapting Circle on Open Keying RISC. The first problem is image rendering. Calling GTK3's interface returns an error message, bad parameters to the lib. The problems were solved by recompilation and loading the static library from the updated the lib package. Another problem is dependency conflict. Pipes depends on libgtk3 devel when compiling, but installing it from the RISC repo results in a dependency conflict. It can be resolved by updating the version of the conflicting package in the repo. In order to provide scalable multi-language functionality for Open Keying, the input method solution team have been working deeply with Open Keying. In terms of national standard support, it provides input support for 15 GBT standard and 5 GB 18030 2022 new minority language characters. To improve user experience, all features have been integrated into the community version. The next generation of Circle input method will also provide a virtual keyboard input support for all minority language characters and handwriting input function. Below is a list of Open Keying multi-language support, including 20 minority languages, such as Tibetan, Korean, and so on. There are also 10 national standards supported, such as GBT 12510 2015, GBT 31918 2015, and so on. Along with a series of products going overseas, such as Beta Roll, Circle input method is able to support the need to provide input local language and script. The script, the cross-platform information, the cross-platform input solution can provide input over 2,000 languages around the world through engine plugins, self-developed or combined with third parties. In addition, it can provide customers with keyboard-like input device, including control keyboard input, remote control panel input, and another non-language single input. Open Keying is involvement in a national collaboration started in 2006 when we participated in open source effort in China, Japan, and South Korea as a leader of the Chinese enterprise group. A milestone was reached in 2016 when we became a full member of the Linux Foundation. In the same year, we became the vice chairman and the deputy secretary general of the China Open Source Software Promotion Alliance. Just last year, we became a platinum member of the Open Foundation. We are continuously involved in open source work. We have contributed millions of lines of code to provide like OpenStack, Linux kernel, OpenNebula, and Fedora. It's not just about the quantity, it's about quality and the impact. Our code component is integrated into the official repos of 11 international Linux distributions. Furthermore, we are not only the contributors, but also active participants. We integrate ourselves to the community by attending international conferences such as LAS, FOSSA Asia, YIPCON Asia, and the Linux Security Summit. As we come to a close, let's continue to work together, share and create for a bright future. Thank you.
Thank you very much. and we have a Vietnamese translation here to wrap up your session. And yeah, you can already. So I can already come to somebody who has a question. Actually. Yeah. Okay. Oh, and in the meantime, already can give the translation. Translation to Vietnamese. Sorry. Yeah. This microphone. Yeah, thank you. To translate in Vietnamese.
Translate.
Yeah. What he said. I mean the wrap up. The you know.
Okay. Bây giờ mình sẽ nói tổng kết lại những gì mà vị diễn giả vừa rồi vừa nói. Vị diễn giả vừa rồi đã diễn thuyết về công cụ nhập liệu sâu cẩu dựa trên OpenKeylin, và sâu cẩu IM là một phương thức nhập liệu rất phổ biến ở Trung Quốc và cũng như ở trên toàn thế giới, mà OpenKeylin là một bản phân phối Linux nổi tiếng tập trung vào bản máy tính để bàn hiện nay. Diễn giả đã trình bày cách họ xây dựng phiên bản sâu cẩu NG với FCRT X5, hỗ trợ cả Qt và GTK, cũng như trình bày sơ bộ công việc trên IM RISC-V đầu tiên của họ.
Okay, thank you very much. I hope that helps a bit to have sometimes some short translation, so we can already set up the laptop for the next speaker and while we answer the questions.
Okay, sorry, I have two questions. The one is, do you support, besides Chinese language and majority languages like Japanese or Indic languages, especially Indic languages where it's complicated to create the glyph stacks?
For the input method, yes, or for the OS?
Input method.
Input method. How your question is how to use the input method to input Japanese, Korea, or other languages?
Yes.
Okay. Most of the language is based on the alphabet. We input them is very easy, type and commit. But in for the Chinese, Japanese, and Korea, we need a convert.
Yes.
So we need a input method engine, and we need a dicta, and we need a UI. Because if we use pinyin, the UI will show the A, B, C, D, E. But if we use non-key pinyin, the UI will show the 1, 2, 3, 4, 5, 6.
I understand. I use it.
Okay.
I use these kind of input methods daily. So my question is, do you support Japanese?
Oh, yes.
Okay. And how is it with Indic languages?
Sorry.
Indic languages like
No.
Hindi? No.
No.
Okay. Okay.
No, not now.
Okay. Then the second question, it was maybe I understood something, but I had the feeling that parts of the input methods is a commercial service. Is this wrong?
Sorry.
A part of the input system, the input is a commercial service. Okay.
Yes.
So you would have to subscribe to a system.
Yes, we use Sogou's engine.
Okay.
That part is commercial.
Okay.
And is closed source code.
Okay. So that's the reason why the compilation problems you had with the libraries. Okay, thanks.
Thank you. Any other questions?
Okay. Not at the moment, yeah. But thank you very much for answering that, yeah?
Thank you.
Appreciate it, yeah? Thank you all very much also for the presentation. And we're coming to the next session in a moment. Yeah, of course, yeah. Thank you. Okay, so give us a moment. We're setting up the laptop, and then this track will continue. Yes, great. So I would like to then also share some information here. So the next session now is about how I built a check-in kiosk for UbuCon Korea 2023 using Ubuntu Frame, Flutter, and Raspberry Pi with Yong Bin. Yeah, and Yong Bin has quite an impressive background. He is an organizer of Ubuntu Korea community, member of the UbuCon Asia Committee, Ubuntu Local Community Council, and he's helping people interested in Ubuntu, its ecosystem, and other relevant open source projects to join and gather together by organizing a lot of community events and local community gatherings in Korea. But actually, you're also reaching out to a lot of other countries and regions. So across the Asian region, of course, it's the focus. And apart from his community engagement in open source, he's a software engineer at CloudMate, a cloud MSP company in Seoul, and involved with developing web products for internal usage. Client companies such as integrated cloud billing portals, sales ops, and much more. Just a short glimpse. But Yongbin, I know our team has met you all over Asia in different places, and you're quite well connected with the FOSS Asia community. So it's a special pleasure to welcome you here. Thank you very much for joining us. And big round of applause for Yongbin. Thank you.
Thank you, Mario, for the introductions. So welcome to my talk. And my talk will be about, Mario already gave you some introductions. It will be about how I built a check-in kiosk with using Ubuntu Frame, Ubuntu Core, and what else? Raspberry Pi. That was a long title. Yeah. So yes, of course, Mario already gave some introduction about me. But to give you what's more, my name is Yongbin, and I'm mostly involved with the Ubuntu community. So usually with the organizing local communities for organizing some meetups or some events like that. So I'm member of the organizer of the Ubuntu Korea, and I'm also part of the Ubuntu Local Community Council, which is a team for the helping out the Ubuntu people who would like to build their local community in the region and help out making that connections across the world. And I am also involved with the organizing a lot of events this year. So I'm a part of the UbuCon Asia Committee, like mentioned, and I'm also involved with the UbuCon Korea, and the annual Debian conference is also happening in Busan this year. So I'm also involved as a part of the local team this year. And for my work, I'm working with the CloudMate for building some services there. So a few notes before starting my talk. It's not really about some kind of best practices because I was new to trying out the Ubuntu Frame last year. So it's just about how I try to use it for my own project. So you may to note for that before listening to my talk. So let's get started. So why we built a check-in kiosk for the events? So when I was organizing UbuCon Asia back in 2022, we were actually using the multiple event platforms for the registration due to some kind of payment issues. Like if we use the local platform, the foreigners, they can register and make payments, and Koreans, they can make payments on the other foreign platforms. So we just decided to use two. And the problem was that we were not able to streamline the check-in process. So there was some missing check-ins, and some people didn't get their tags, and so there was some kind of problem. So if I try this kind of event once more, I want to improve that kind of check-in process at the event. So I started to work in my own kiosk project. And why I choose to build on top of the Ubuntu Core and Ubuntu Frame? Well, I've been to Ubuntu Summit and UbuCon Asia back in 2022, and there was actually a lot of talks and workshops about the Ubuntu Frame and how you can build a kiosk or digital signage built on top of that. So it really catch my some attractions. So after participating those kind of some sessions, I went to try building some of my own projects on that. So that was the reason why I choose that. So by the way, what are Ubuntu Core and Ubuntu Frame? To give you some short introductions, I think you already know about the Ubuntu, right? It's one of the most popular Linux distributions in the world, and the Ubuntu Core is a kind of operating system optimized for the building your IoT or edge computing or embedded devices. And one of the biggest notable differences between the Ubuntu and Ubuntu Core, that would be everything are snap packages in Ubuntu Core. Like even system updates are managed with the snap packages. So that would be the biggest difference. And the Ubuntu Frame, while the Ubuntu Core is like that, and Ubuntu Frame is basically a kind of full screen Wayland shell. It's built on top of the Mirror Display Server. So since it's basically a Wayland compositor, so if your Linux GUI apps compatible with the Wayland, you can also launch that inside the Ubuntu Frame, and you can use it like for kiosk or some digital signage for that. So since the Ubuntu Frame is also packaged as a snap package, so that we can run it on the Ubuntu Core, there is something special things you need to set up for using the Ubuntu Frame, which is called interfaces. Like it allows you to access some system resources, something like Wayland socket, like system, your text input screen, yeah, like that. And so you usually configure the connection, interface connections to allow your GUI app to communicate with the Ubuntu Frame. So that was short introduction about the Ubuntu Core and Frame. So this was basically my original plan for building my kiosk. So my plan was to, of course, using built on top of the Ubuntu Core and Frame, and I had some existing webcam, so I wanted to use it for scanning QR codes, and I also wanted to try out the working with the Flutter apps, because at that time the Flutter support for the Linux was also promoted a lot, so I also wanted to try that with the Yaru Dart, which is a Ubuntu style theme for the building your Flutter applications. And well, on that time I also got a RISC-V board, but yeah, I wanted to try it, but I was not able to use it because Flutter didn't have support for the RISC-V at the time, so I just replaced it with the Raspberry Pi. And yes, of course, we also need a cheap library printer for printing some tags. So first thing I did for my project would be finding a cheap label printer, because if you search for the label printer, you usually find the printers from the something like Epson's or Jabra, and of course they're very good printers, but they're very expensive, right? And it doesn't make sense to buy those expensive for just your hobby projects. So I thought I started to search for some AliExpress for cheap printers that seem to be work with Linux. And this is what about. And yeah, it worked with Linux, but it only worked with the x86, and it didn't work with Raspberry Pi. So I was not able to use that driver to make some label printing. So instead, I tried something alternative way. Like if you look at the label printer, they have their own programming language, something like TSPL, GPL, or ESCPOS, you can use it to directly control your library printer. So I have tried out the GSPL, which wasn't easy for me. Well, and I also did a lot of workarounds with printing properly. So I was also trying to see how other mobile library printer apps, they are sending commands to the printer. And like if you look at the printer, they have a dump feature. You can dump the comment data from the application, and this is what I got. A lot of labels printed in just a second. So this is how this build command looks like. Well, it was one of the command lines supported by the printer about, and so it looks much easier than ESCPOS. So I decided to use that. And when you're using it on Flutter, you can build the command like that. And after that, I started to work with a Flutter app for implementing some features. Like first thing what I did would be building a QR code scanning feature using the, well, Flutter is a camera program, but they don't have support for the Linux. So I just look for some plugins that work with the GStreamer. Well, I think I was able to implement it. So I implemented QR scanning with the webcam first. Then once I had built some part of my apps, I started to work it, testing it on my desktop first, like my working machine, like laptops. Like you can actually test it very easily. Like if you're running Snaps on your laptops, and you can just install Ubuntu Frame Snaps and just run the Ubuntu Frame with some environments. Like you can use the Wayland display environment for configuring what kind of socket you will be using, and then you can just launch your app inside, like this. Like if you launch the Ubuntu Frame, like I said, it's just a full screen shell. It gives you the empty screen first. Then if you launch your application inside, now that's what you got. Yeah, you see your application launch inside the frame, and you can interact with the application. Now that you have tested your applications, next thing what I did would be writing a Snapcraft YAML. Snapcraft YAML is kind of a configuration file for building your Snap package. So Snap is actually like similar to Docker container in terms of bundling dependencies you need to run required to run your applications. So if you're familiar with the Docker files, maybe you can also easily start with the Snapcraft. So you define your Snapcraft, and inside you define what kind of dependency you need, and yeah, something like that. And there's something a bit tricky when you're working with the Snap for the Ubuntu core, because the environment is quite different from the package for desktop. So you can really take advantage of the desktop extensions, but fortunately there are many some example projects that you can build on top of it, so you don't need to start from the scratch. And another different thing from your normal desktop application, that would be it's launching as a daemon, so that you can so that it will be launched automatically on boot of the Ubuntu core environment, and it will also not interrupt your command line prompts after you launch your applications. So then, after you have defined your Snapcraft, I also started building this app. Well, you will normally build your Snap package for your laptops, but in this case, we're gonna build it for the Raspberry Pi. So, but I think, well, usually cross-compiling is a bit quite complicated to set up. So you can actually leverage the existing infrastructure. If you look at the Snapcraft, CLI, which is a tool for building the Snap. There's a remote build command which you can leverage the Launchpad infrastructure to build for some other CPU architectures like ARM64, like that. Or if you want to automate the build of your Snap, there's some GitHub actions that you can use it for working with the workflow. Like there's a Snap Core action build actions that allow you to build your Snap. And well, you will also need to build Snap for the multiple architectures in case that you can use the Snapgraph multi-arch actions for cross-compile your Snap for some multiple devices like your PCs and Raspberry Pi and much more. Then, since I have built my Snap, now it's time to test it on the actual machine, like Raspberry Pi, like used for the building kiosk. Like, well, setting up your application in Ubuntu Core is also quite straightforward. Like, if you already have Ubuntu Core installed your Raspberry Pi, you just need to install Ubuntu Frame Snap. Then, like, you will need to copy your Snap over something like SCP. Then you can just install it. But you need some dangerous flag because you're installing your local package. So that will allow to install your package for the file. And one thing you need to note is that I mentioned about the interfaces earlier. So you will also need to connect the interface, the relay interface, so that your application can talk with the Ubuntu Frame and you can interact with your applications. So for my use cases, I also have some scenario for that. People need to enter their emails for checking in. So I also add the on-screen keyboard. Adding the on-screen keyboard is also quite straightforward. Well, there is already a Ubuntu Frame OSK Snap. Just need to install it on your device, and it will basically automatically configure and launch. So, well, there's really nothing to do. It just works. So this is how it works in actions. My the kiosk setup I have built on the on-site. So if the people touch the text input on the screen, then the on-screen keyboard will be enabled. And well, but actually not everything was straightforward. Like mostly something like if you're new to working with Snaps, like working with interfaces would be a bit tricky because you might not know what kind of interfaces you need to add. For that, you can use the Snappy Debug. It helps you find what kind of interfaces are missing on your Snapgraph. So you can use that for debugging. But even after that, there was some many things like tricky to work with. One of the things would be like I have found that it's working. The QR code scanning with the webcam is working on my laptop, but it wasn't working on the Raspberry Pi. And now the problem was that I was not able to fix it like while the deadline is approaching. So for that, I just decided to give up and just borrowed the QR code barcode scanner from my friend and replaced the scanning feature with some like text input because the barcode scanner gives me some keyboard input, so I was able to easily replace the implementation. And I also had some problem with the Trick USB, the plugin. They only have support for the x86, so didn't work with the Raspberry Pi. So I also need to do some weird workaround. I wrote a simple Python server using the Pi USB. And yeah, that was I have made the setup anyway. And another problem I got on the on-site where I'm setting up was that it was the network configuration issue because the venue, they did provide the Wi-Fi, but it has a captive portal, which means you need to turn on the web browser to log in. But in the Ubuntu core, we don't have the web browser, so I was not able to connect the Wi-Fi. Instead, I just hook up Ethernet cable with my laptop and just share my the network connection. Well, it was a workaround, but work anyway, I think. So let's have a look in action, how it works. So that was how it actually worked in action. Oh, yes. So I told you there was still some couple of issues. Even I able to set up on site. So I'm still trying to improve after the event because I need to use the same setup and the same event this year. So what I'm trying to work it first will be adding a network configuration interfaces so that I can configure network on site. So I was actually able to implement it using the NM package, which is allows you to it's a folder package that allows you to interact with the network manager, so that you can configure the network connections on your Linux systems. And there are actually many packages available already that allows you to interact with the Linux system, something like Dbus, Bluch, and much more. Yeah, I'm also thinking about some kind of how can I deploy much better. Maybe I can try out some OTA feature that SnapStore provides, or I haven't tried out yet, but I think I can also try using the Gadget Snaps. I heard that it's for the adding some like including configurations in the Snap packages, so that I can deploy in the multiple machines much easier. So that was my use cases of the Flutter and Ubuntu Frame. So to summarize my thoughts on these technologies, like I think the most things were quite straightforward. Something like working in Flutter for Linux. They have already many tools available for the Linux and packages also available, so I can work with on using my VS Code and my Ubuntu desktop. And using the Ubuntu Frame and the Ubuntu Core was also using itself was quite straightforward, but I think the building a snap for that environment was quite tricky because what I need to bundle would be quite different from the desktop snap, so that was something tricky. And yes, the working with the network on site, that was I think that was one of the most tricky things when I was working with the Ubuntu Core. So that was for my talk, and just before I finish my talk, I have something to advertise. So there is a UbuCon Asia happening this year in Jaipur and India. It will be happening around late August to September 2nd. So we are currently calling for proposals. So if you would like to join, you can scan the QR code for more details. And we're also calling for sponsor for the event. And the annual Debian conference is also happening there, happening in South Korea. So we will be calling for proposals quite soon. So if you will be interested, you can also scan QR for details. And yes, we're also calling for sponsors for the Debian conference. All right, that's all for my talk. Thank you for joining my talk. And if you have any questions, feel free to visit the Korea Falls Committee booth on the second floor. Thank you.
Okay, thank you very much. And you are there tomorrow the whole day at the booth where we can find you, right? Yeah. Okay, cool. Thank you. And we have the next speaker coming up. Yeah, with the next talk. The talk is about open source operating systems in higher learning and research with Jerry Vasquez. Yeah, is that correct? Or you speak that in like Spanish way, Vasquez, yeah, like the English way. Okay, so Jerry is a seasoned Linux and networking engineer at the Facility for Rare Isotope Beams at Michigan State University, where he is known as the OJ leader, Linux bird Chia pet, and an accidental network engineer. Okay. With a fascinating journey from chef to tech leader, Jerry brings a unique blend of skills to the table. His background is in professional kitchens, honed his abilities in quick decision-making, accountability, effective communication, and urgency, all of which proved invaluable in the tech domain. Transitioning from culinary arts to network engineering, Jerry has applied his leadership and operational skills to significantly improve network uptime from 96 to 100% within a year, manage a diverse team of 20 network engineers, and foster a culture of continuous learning. His leadership philosophy emphasizes personal accountability, the value of each team member's contribution, and the importance of collaborative team environment. I'm sorry for the mistakes. It's a bit getting late here, quite right. But we still quite a number of people who'd love to hear a story, and we have 30,000 people watching online here at the moment from all over the world, all over Asia and China, everywhere. So big round of applause for Jerry. Welcome.
You didn't have to tell me how many people were watching online. That is nerve-wracking. Thank you. I also didn't expect him to read the entire biography because I put some really funny stuff in there. 15 minutes, we're running super late. I know everybody wants to get to the event, or the people online probably want to go and have a snack. So I'm going to jump right into it. He gave me a good bio, so I'm not going to give much of an introduction. Yeah, let's move right into it. Open source softwares in higher learning specifically. So there's a big timeline of computer and computer things. Back in 1939, Bell Labs created the first real calculator, the calculating machine. 44, the Colossus machine came around that was actually able to introduce vacuum tubes into computing. So you had the two of the big primary things for computing, which is processing and storage. The Colossus machine was also one of the machines that was using for deciphering codes and such during the World War II. That's pretty cool. But at that point, it was mostly not US, but mostly governmental environments and organizations that were doing all of the complicated stuff with computers. So 48, the University of Manchester was one of the real big moves from governmental companies or governmental organizations into higher learning organizations to actually start pushing computing forward. And that was 1948 when they made the Manchester Baby. That was the first machine that introduced RAM. So now at this point we have processor, we have RAM, we have storage. So we got the three things that actually make up a computer. Now, at this point, computers were freaking huge, right? The entire size of the room. So Digital Equipment Corporation came through and they created the first self-contained programmable data processor. They didn't want to call it a computer because a computer was massive, and this was self-contained and was trying to get smaller and smaller. And that started in 57 and it went all the way through 90. The first couple iterations, they broke some great ground because they were starting to get self-contained, but they didn't actually sell very much. The PDP-3 only sold 1 unit, and it was to the CIA, which is kind of wild. But however, when they moved into the 6s through 11s, it started going into universities primarily. And that's kind of where we get started with operating systems and where it started to influence in universities in particular. So at that point, there was, the PDPs were given to a bunch of universities, and universities were actually starting to work together a bit, and you would end up in universities, like most of you guys are here, you would see these kids who were able to just hack up code and hack up stuff to make the thing work. And that's kind of where the term hacker came from. And so you end up with these college kids who are actually a community of tinkerers that were trying to get this stuff to work. And the cool thing was, when they were a community like that, they were able to share their successes and share their failures with one another, commiserate with one another, and start to really share the things that they had and that they believed, that they came up with and that they were able to solve. So one of the awesome things at this point, because of the sharing and the collaboration that was going on, it was considered a professional courtesy anytime you put out some sort of instruction, some sort of operation, some system that would manage operations on a computer, that you would offer the source code along with it. But that changed a little bit in 1980 when Richard Stallman decided to fight a printer. So Richard Stallman was working at MIT at the time, and the MIT was given a printer by Xerox, and this was the very first real printer like the printers that we know. At the time, Xerox was making the photocopier. You put a piece of paper down, it makes a copy of it. This one, you actually took data, sent it over the network, and put it onto the printer, and the printer decided to print it out. And it was fantastic, except it had a few problems. There were some issues with the networking specifically, lots of paper jams, of course, because they always had those. But there were some situations wherein the data would go from the machine on the network over to the printer and get lost somewhere in the pipes. And the only way to address that was to actually work with the operating systems that was maintaining the computer itself. Here's the problem. Xerox decided to send the code not paying attention to the courtesy of including the actual source code with it. They compiled it into binary, so all it was bits and bytes. And Stallman, although he was a good programmer and a great engineer, he didn't really do too well with bits and bytes and such. So, remember I talked about that community of folks and community of hackers. He decided to go to Harvard. Now, at Harvard, they had 2 machines. Also, they had a PDP-10 originally. That was actually the machine that Bill Gates wrote the first version of BASIC on. And they got themselves a PDP-11, and they weren't able to talk to each other. So what they did was Stallman reached out there after they figured that out, and he told them, hey, I'm working on this machine that's got a similar network issue that you guys are seeing with the PDPs. Can I have your source code? And they gave it to him because that's what hackers did at the time. That's what people in community do when they're working with community-based operating systems. We share stuff. And so he shared that with him. He was able to update the code and fix the issues. And that's fantastic. He was able to go forth and do also, now at the time, so that was like the first real situation wherein there was an operating system that was being openly sourced, where the source codes were available to whomever. And that's fantastic. Of course, OSs went all crazy from there. Unix was made by Bell Labs. BSD came off, which is based in Unix, and just turned into this big legal nightmare. DOS eventually came out from Seattle Computers. The GNU project was started by Stallman, and then it kind of fell flat, and it really didn't take off the way that he wanted to. Windows ended up, Microsoft ended up purchasing DOS and then building Windows off of it. And then, at that point, you had a machine that had an operating system, but the operating system belonged to the people that sold it to you. You couldn't touch the operating system. You can change configurations, you could make it do stuff, but you don't get the code. And tinkerers, hackers, people like us, like to look at the code. We like to have our own systems, like the gentleman before me that was working on his system. He wanted to take a piece of machinery and make it work for himself. He needed access to the code. And so, 1991, Linus Torvalds out of Helsinki decides to to write an awesome operating system that we know as Linux and just give it to everybody. Anybody who wanted it could have access to the source code that could actually drive a computer that we have right now. And that's fantastic. And Linux just blew up from that point because it was free, it was open, it was customizable, it was available. And so now we got a Linux on all of the top 500 supercomputers, 23 of the top 5 websites of the world right now. Actually, this is as of 2023, so this might be a little dated. 96% of the world's top million computers and 90% of all cloud services are running off of Linux right now. And it's a free open source software that everybody uses. And these people are making lots and lots of money off of this stuff. And that's fine, that's fine. But the base of it is a free and open source piece of software that started out with a base in higher learning and in research. So here's the weird thing when we talk about research specifically. Now, before I went into the research area, before I became an engineer, so right now I work for a linear particle accelerator in Lansing, Michigan, in the US. But before I started working there, I worked in web hosting, and like my bio said, I was a chef before that. This is the first time I've ever worked in a place where we didn't create a product. And that blew my mind when I first considered it. Like, how do you pay for stuff? How do you create things? What's the drive behind that? And the reality happens is that because we don't make a product, it fundamentally changes the way that you look at the work that you're doing. You don't get funding quarterly because of how many things you sell. Most of the time, funding comes in the form of grants, where you try to get as much free work as you can from folks who are just really interested in things. And the crazy thing about grants, at least in the US where I'm based, is grants usually come from the government, and the US government can change over every 4 years. So you can get a grant that's great and it's moving, it gives you all this money, but then 4 years, it's just gone. So what do you do with the money that just changes out of nowhere? You end up employing people that are actually seeking out knowledge and looking to push forward the boundaries of society as we understand it. That's what science does. Technology changes quickly. Every 6 months you get a new version of something. Every 3 years you're obsolete at that point. After 3 years, most folks that are working in technology are looking for a new job. But science doesn't change. The numbers doesn't change. Only technology moves quickly. You plan, you test, you plan, and you keep on going from there. So let's get back to Linux. At CERN, at FRIB, at Fermilab, at NERSC, they're all using Linux to drive so many of their great research that's, like I said, just changing the world as we see it today. Why? Well, like I said, that first part about the funding is a big thing. Funding, it's free, so you don't have to worry about having to change the way you're funding or when something just changes randomly because we get a new administration. Not just the new administration, but we're college kids. Well, I'm not anymore. I'm an old man at this point. You guys are college kids right now. You're not going to spend money on the stuff that you're studying, gaming, right? When's the last time you actually spent something on the work side? I tell you how much money I spent on my gaming stuff, especially when I was at your age. That and going out and have a good time every so often, a few drinks. Anyways, I didn't say that. So it's customizable is the other cool thing. Super granular, all the way down to the hardware itself. You can change the actual way the bits and bytes interact with the specific hardware as it goes. And not to mention, that goes along with that is built into the way it was actually created way back in the day is this community that comes with it. All these folks, we're a community of tinkerers that just like to make things work and like to share what we got, share our successes. And so that means that Linux really moves forward, really helps to move that stuff forward. So we're looking at science specifically. What's the big deal with science? So I had to learn the hard way, honestly, that science isn't science unless it's recreatable. You can't just make one quick discovery and decide that you've changed the whole world or you come up with a new paradigm. Science isn't science unless you can come up with, you can find those discoveries, you can do those testing, and then you can share it with the rest of the people that have been working on it. And it's not important unless we're actually learning something and you're doing something new. Also, science moves incredibly, incredibly slowly, like I was saying earlier. And we don't create things, we break ground. So, with that in mind, we're going to move, so with the idea of science where we are right now, we're going to move into what we consider the future. And anytime I talk about the future and I talk about technology, somebody wants to tell me, how do we use AI with this? The future of research isn't AI, and I'm very sorry that I had to say that. I can't tell you when the Matrix is going to happen, and I can't tell you when the Terminators are going to attack. Because that's not what science does. Science moves much more slowly than the technology we had yet. So when we're looking in the research, the OSs that research is going to favor as you move into the future are going to take those fundamental ideas that I gave about science early on and kind of build off of them. And the first thing is that when you're breaking ground in research, you're trying to figure out how things work. And fundamentally, as our technology has grown, the way things work is just getting smaller and smaller. And my job specifically, we work with subatomic particles, little neutrons that are kind of shooting into the atom of a nucleus. It's tiny, tiny, tiny. And we're talking picoseconds. The picosecond's a millionth of a millisecond. It's crazy the way that they're measuring this. So not only smaller, it has to be smaller, it has to be lighter weight, and it has to start to move much more quickly because you're capturing these things. Like the Higgs boson was recently discovered in CERN. Rather, it was recently proven to be discovered in CERN. It was already proven via math. But they actually found it, and it exists for something like a millionth of a picosecond. It's a tiny, tiny amount of time. So the operating system has to be able to keep up with those sorts of discoveries as well. On top of that, our world is getting smaller. And that's good. We can share this stuff out with the rest of the world and with the rest of humanity and help kind of push us forward. However, that also means that there's a chance that bad actors can come around. So operating needs to also maintain some level of security and some leg-mindedness about how we're going to make sure that bad actors don't misinterpret or take the research that we've been doing and use it in a nefarious manner. And the last thing, because science moves so slowly, we're no longer looking at 3 and 5 year terms of support. The longer the amount of support, the more. When I was in CERN, I got the great opportunity to go and visit CERN, and they were working on a project right now, breaking ground and doing planning and finding funding that doesn't actually start till 2045. We're talking 20 years in the future. So if we're starting to look at the operating systems that are going to be able to manage that product, we have to look at longevity of the support that's actually going to come from those guys. So that's kind of what I had today, a quick 15 minutes introduction into where we are with operating systems and science. We have a whole lot of ground that we can break. We're learning stuff so quickly. We've got a whole bunch of fresh minds. It's you guys specifically that are out there like willing and able and looking forward to do something awesome. And you'll find, I think, that using these sorts of open source software is going to be one of the fundamental backbones of how we actually push ourselves forward. So, hope that was all right. Thank you guys for the lovely time.
Thank you very much. Yeah, like quite impressed, like how you get the audience really clapping like so loud and like excited, like yes. But like yeah, are there any final questions in the room? Okay, I have a question here.
Do we use only Linux for this open source science works?
No. So there are lots of different pieces of software that are involved in it. There's lots of Windows, there's lots of Linux, there's lots of Mac. There's a whole bunch of different flavors. You find that in some of the pieces of hardware that require more customizability, they do turn to Linux, however. And it's mostly because they can change things and cut things off as they need to.
Yes. Have you applied what all you explained to us for any science project or any of your work?
Oh yes, absolutely. So most recently at the FRIB, there was a science experiment which discovered the drip line for the sodium molecule. And what happens is, I'm going to try to dumb this down as quick as I can. An atom can only hold so many neutrons, and you're trying to add more neutrons to it. And in the process, we got these two big beams that are moving together. And they're converging right in the middle. And they splash against the backsplash. And the hardware that captures it is running Debian right now.
Is it electrons, I believe?
Yeah, electrons and neutrons specifically.
Yes, yeah. Thank you very much. Wonderful presentation.
Thank you.
Okay, so thank you very much. That concludes the session and the track. We're back tomorrow here. Yeah. Jerry, people love you. Great, great. Thank you very much for giving back this energy here to the stage. The whole day, been a fantastic audience, and we can't wait to see you again tomorrow here at the FOSS Asia Summit 2024. Goodbye.